Hold on.
It's great to be on.
Hold on, Sean. Hello,
Okay.
everyone. Welcome to the Fringe Think Tank. I'm Old Man Bill, otherwise known as Nathan. We have Sean Calderon on here today, and he's going to present for us. And we're going to be talking about some cool little Tesla coil stuff and some other stuff. Whoop. I have my stuff on. I shouldn't have done that. Sorry, Sean.
No worries.
All right, let's go ahead. Let's get to your presentation. Let me bring it up. You want to say hi to everybody real quick?
Yeah. Hey, hi, everybody. It's great to be back on Nathan's channel. I'm hoping to share some of the things that I'm working on. And so let's get to it. Nathan, first slide, please.
Yeah, absolutely. Here we go.
All right. You didn't expect this slide to show up, huh, on a status update of my projects. So what I've done is I've taken this device, it's supposed to be for your skin. It electrocutes your skin. And I ordered it to turn it into something else. So I just wanted to show you that. So I'm on Amazon. It's only $33 if you get the free shipping. But I'm going to show you what I did with it. So next slide, please. So this is the box that I ordered. You see that there's 4 colors there on the lower left corner. There's a purple, a blue, a green, and a kind of gray. Those are the different evacuated tubes with what they call noble gases in them. And so those are the colors that they can emit. Next slide, please. When I open the box, this is what you see. You see this sort of rocket-shaped object, and then you have these glass tubes. And so how it works is you'll put the glass tube in the tip, and then when you switch it on, electricity comes out and excites the gas inside the tubes, and then you get the colors. And so the treatment is you're supposed to take that tube full of electricity and run it over your face. It's a Chinese healing device, basically. Next slide. So what I decided to do is turn it into something else. And so here you can see that it unscrews right here in the mid part. And so you can start to see the circuitry in there. And Nathan, is it possible to get the slides a little bigger? Awesome. So this is what it looks like when you open it up. Next slide. There's a screw on the tip. So you want to take out that screw because that's going to then fully take apart the device. Next slide. Inside the device, you'll see now is a black cylinder. That is basically a transformer, a high voltage transformer, and it's set in a black epoxy or a black resin. And the circuitry there coming out on the left, those big purplish capacitors, that's a circuit that takes the mains electricity from the house and it steps it down so that black coil there can put out some electricity. Next slide, please. So what I did is I took the wire cutters and I began to clip off the plastic around the point where the electricity comes out. Next slide. If you've ever bought a multimeter from Klein or other groups, you'll get these sort of brass needle kind of points. And so I have a couple cheap meters, and these came with them. So I'm going to use one of these tips for this device. Next slide. All right. So if you look to the left, I also did some work on reducing the size. There on the bottom left, you can see the clippings there on the left. So when I took the wire cutters, you can see now that the needle peeks out of that black cylinder. Next slide. In order for this to work, you have to wrap a few windings of tape, and then this will enlarge the cylinder so it fits snugly when you put it back together. Next slide. So once it's put together, it looks like this. You have the cylinder coming out with that brass point, and you'll notice that this thing is shorter. The device, the white part is shorter. Next slide. And there you go. You have a handheld Tesla coil. This only took about 15 minutes, but this little gadget is a blast. So I don't know why it is, but I love electrocuting everything. So I'm going to show you some videos of how I have fun with this. Next slide. So one thing I wanted to show here with this slide is that I've grounded one end of this light bulb, and now I'm just touching the other end of the light bulb with this Tesla coil. If you can keep playing it, Nathan, that'd be great. So what it's doing here is it is a live circuit. This is turned off. It's not dangerous to touch, though I don't recommend it, and I don't want to be responsible for if someone doesn't know how to use this and gets hurt. But if you can put your face on it, I imagine that it's relatively safe. But when turned off, it has a 115 or 120 voltage. And that sort of made me wonder, ooh, is this dangerous? But what I did after this is I measured the current that's going through the light bulb, and it's microamps. So it's such a small current that it's really not dangerous at all. Even though the LED diodes, they get pretty bright for such small amperage. Next slide, please. So here I grabbed just a circuit board, nothing fancy, and it's a plain breadboard type. And I'm running electricity from the end of the Tesla coil, the handheld Tesla coil, and you can kind of see the amazing designs. They're all going into the ground, which I have a large ground at my house. And so this was one of the fun things that I did. Can you zoom it out in a little bit, please? Or our video's harder. Sorry about that. So on the next video, please. This is another different breadboard. Oh, I think you skipped one, Nathan. Could we go back one, please? Here we go. So this is a completely different empty breadboard. Oh, I'm sorry. Sorry about that, Nathan. I have a little bit mixed up. Okay, so this is a regular breadboard that I explained earlier. Next slide, please. All right, so this is a neon lamp. I'm touching the tip of it with this little Tesla coil. It's going into a circuit board that's going into ground, and it's lighting up LEDs. So this electricity likes to travel. There it is on a pen that I just had laying on the desk. I'm just having fun electrocuting things. Next slide. So again, I focus in on the pen. There's some alloys in this pen, which causes the plasma discharge to go into these fractal shapes, and also to change color. So it's just fascinating what you can do with just stuff laying on your desk, and it's just a blast. It kind of looks like a electric spider crawling on my desk. Very cool. Next slide, please. All right, so I connected the oscope to the device, and this is the signal that goes through it. So it's just a flat line until it starts ringing. So when you go left to right, flat line, then it starts ringing all the way to the top, to the bottom, to the top, to the bottom, but it starts to decrease until at the end, it starts over again. So you go left to right, and this frequency of this device is 185 kilohertz. So 185,000 rings per second. You're going to see this. So it's quite a fast high frequency. Next slide. So that ends the device. I'm sorry, the handheld Tesla coil build. if you guys want to rewatch those and purchase your own, these steps you can follow, and you can have your own handheld Tesla coil. Another project I'm working on is a 6 MOSFET ZVS to power up my high-powered new coils that I'm winding. And so if you look at the top left of the screen, you can see how much bigger the ZVS board is to the ZVS board on the right. And so if you recall, you were watching my last video, I was using the ZVS on the right. And so the reason why for 6 MOSFETs instead of 2 is you can get more current, and these are rated about 50 amps. So the little one on the right, 7-8 amps, the one on the left, up to 50 amps. And so I really wanted to push the current into my new coils. And so I'm experimenting, and I'm having a few little successes, but I'm not quite there yet. But I just wanted to share you guys just a brief update of what I'm working on. Next slide. So here's a diagram of the ZVS Tesla coil. I'm using the sphere. The sphere is a bit beat up because I get the sparks to come out the side. It's not intentional, but it tends to melt and burn. But what I'm showing you here is that this device is kind of a bit precise. It needs lockdown variables. They have to be consistent. If they're not consistent, then these 6 MOSFETs, if you can think about a 6 piston car, 6 cylinder car, and it's not firing on all 6 pistons, that's what these MOSFETs do. Now, when they're running well, 3 on one side are on, while the 3 on the other side are off, and then it switches. Then the bottom ones are on, and then the top are off, and it does that based on the coil that you see under the sphere, that piping you see there, the copper pipe, and that little capacitor there in blue. So if I have the capacitor at a certain value, and then I have that copper pipe at a certain value, then that's going to determine the frequency. And if I can get that frequency to equal the frequency of that sphere, and then what will happen is we'll see sparks come out the end. And so when I show you that concave shaped copper tubing, it needs to be locked down in the spacing. The gaps have to be perfect. If those gaps change in the slightest, you'll lose your frequency, and you can actually burn up your MOSFETs. And so you have to have the copper pipe spacing to be perfect. The concave shape also has to be perfect at the perfect angle. Another thing is, if you'll look under the sphere, you'll see an acrylic piece of acrylic tubing, and that has to be sized correctly. So that way the sphere is in the correct height in order for it to be a balanced system. If any one of these variables is not right, what you'll see is you either will burn up a MOSFET, or the sphere will catch on fire. So, and don't worry, I have a fire extinguisher. So, and I do wear a face shield when I get these working. You also notice here there's an O-scope probe on the bottom left, and it has a little piece of wire in it. That's my antenna that goes to my O-scope, and that lets me see if I'm achieving the frequency in order for the sphere to resonate. Also, if you look on the right, I mentioned a couple more things. Those wheels, those circular objects over there are called chokes. What they do is make sure that the current doesn't come in quickly, but it regulates the current, so there's no changes in current. That's why they're called chokes. They choke off the current, make sure that it doesn't go up or down too fast. There's also in white, you'll see their number 7. I put in 6 high-speed diodes, and that really helped this because these MOSFETs really need good timing. Next slide. So here This is my first time I'm getting this thing really fired up. I'm within 10 kilohertz of the resonant frequency for the sphere. And so what'll happen is when I get perfectly to the resonant frequency of the sphere, this plasma discharge, these sparks, they'll triple or quadruple. They'll be almost as large as the sphere. So that's the goal, to have this output to be resonating within just a few hertz, and just watch that needle on top of the sphere to just go crazy. So that's my goal. Next slide, please. I'm starting to print a new sphere. Instead of black, I picked iridium gold color, but it's a PLA filament, and it's matte. I usually like the PLA, so what I do is I buy the colors that nobody likes and that go on sale. And so people didn't really like this iridium gold, so I got it for a cheap price. And so here you can see I'm 3D printing the new sphere. Next slide. I also printed the forms. And so once I'm done wiring the gold, the new gold sphere, I'm going to place it in there and do the epoxy. So it's covered in epoxy. Next slide. So this is kind of sloppy looking, but it's actually very useful. If you look to the left, you'll see upper left corner in green, you'll see 220. And then in green, you'll see 330 under that. And then under 330, you'll see 480. And then if you go below that, you'll see 6.8. Now, when I'm trying to look for particular capacitor values, I just don't want to buy a different value capacitor for every one of my prototypes. I would have a large collection of capacitors, and it would be too expensive. So what I do here is I look at this chart. So let's say I need a certain value. I need like 660 nanofarads. Well, I can see that that's number 3 on the line up in the left-hand corner where it says 220. Then there's 440, and then there's 660. And so I can just add those up in parallel, and those 3 capacitors, and I have my 660, and I'm ready to go. But let's say I needed 73 nanofarads. Well, then instead of connecting them in parallel, you connect them in series. And if you connect them into series, you'll see here that under the 660, it says 73. And so what happens is when capacitors are connected in series, they go lower and lower and lower in value. So if you go all the way to the right to the 10th capacitor, the upper right, you'll find that, okay, I'm in series with 10 capacitors, but I'm only getting 22 nanofarads. And so, so this is really handy for me. I use it to pick the capacitor values that I need and get back to my prototyping. Next slide. Just another quick little update. I showed last time that I buy in the kitchen area of thrift stores, I buy these acrylic containers that usually have like cookies or noodles or something. And that's how I store all of my electronics, so I can see through and I can see my capacitors, or I can see my inductors, or whatever I need. So I'm back now here to share a miscellaneous here. And this is where when I go to the thrift store, I buy stereo receivers. And sometimes they work, sometimes they don't. But inside is these amazing toroid coils. And they're wrapped with all kinds of outputs and inputs. And so I'll pay $10 for this broken receiver. And you can price these things. They can be as high as $1,000. And so one of the main uses for these is that they're very efficient power transformers. So they're the transformer that powered the device. Next slide. So I found this deal of this Technical Pro stereo receiver, 1500 watts. I got it for about $5-10 bucks. And so next slide. And there we have another toroid power transformer. So these are the nuggets that I like to find at the thrift store. And so what I'll do is, as I lift up each stereo receiver, if it's heavy in one corner, I know it's going to have this toroid transformer, and so I'm going to buy it. And so I just thought I'd share that. Next slide. Next slide, please. Or is this the end? I think it's the end.
Yeah, Sean, that was the last one.
Thank you, Nathan. Thank you, everybody, for listening. Does anybody have any questions?
Okay, let's go through the audience. We had some stuff. Okay, hold on one second. Let me mute something.
Okay.
There's something going on in my background, and I don't know what it is. Anyway.
Okay, I'm not hearing anything in the background.
Oh, okay. So we might be good. All right. Sorry. Might just be me.
No worries.
Okay. Nice. Getting some applause. Thank you, Sean, by the way. I'll be the one clapping for you. Thank you for doing that. I appreciate it.
Thank you. Means a lot. Yeah, Nathan does a great job.
Let's see. That device was actually making a high voltage ozone plasma to sterilize things. Is that about what you think? For somebody's acne?
Yeah, that's they're supposed to rub it on their face to get rid of acne or give them a fresh look in their skin. But if you put that vacuum tube in that slot and turn it up, I mean, you're electrocuting your cheek. I mean, I don't know how people do it, but the idea came to me, oh, wait, I can make this a handheld Tesla coil and electrocute things all over my lab. And that's fun.
Oh, that sounds like me. Now you're starting to sound like me. No wonder why we get along. We just electrocute everything.
That's right. That's right. Thank you. Appreciate it.
Everybody's saying hello.
Thank you, sir. Ma'am.
Stay grounded. Okay. Oh, we got some temperature readings here. Okay.
All
right.
F11 makes a full screen.
Oh, that's probably me because I'm over there doing the controlling. That's my fault. Loving winter weather. Okay. Okay. Are MOSFETs cascaded?
That's a great question. They're not. Basically, there's one side of the MOSFET's 3. If they are turned on, then the other side, the MOSFETs will be off. And then it just reverses back and forth like that. They do that for current. So they're connected to get maximum current, but no change in their voltage rating. And so the current is important because the ZVS board is actually made for the induction heater, and induction heaters need lower voltage, lower frequency, and lots of amps. So what I'm doing is just taking that induction board and changing it into a Tesla coil. And in my next update, I'll be souping that thing up. I'll have it like a hot rod next time. Good question.
Okay. 50 amps.
Yes. And 1,000,000 volts. I've always wanted to reach 1,000,000 volts. And
hold on. Is that thing going to reach 1,000,000? That six-sided one?
Not with 50 amps. No.
Okay.
But I can use those 50 amps and turn them into voltage. So yeah, that's my goal. 1,000,000 volts and on the desk.
Nice. All right. We're going to have to look out for that build right there because that's going to be amazing. I don't know that you would necessarily share that with everybody because that might hurt, but
yeah,
I would do it.
I might have the FCC saying, blaming me for my own radio channel.
Yeah. You turn it on every once in a while. Sean's broadcasting somewhere.
Yes.
They start showing up in their vans.
Yes. And one of my goals for that 1,000,000 volts is to turn it into a radiant energy for wireless power. It would be
Okay.
really interesting to power everything in the house wirelessly. That's a big goal. I know how lofty that is, but I like to aim for a star. And if I hit the moon, that's great. I don't want to aim for a mountain and hit a molehill. So that's my goal.
Definitely not hitting molehills with that. You're going to be
Thanks.
putting energy everywhere. All right, we got
Yeah.
90 degrees. So you went what, 30 degrees on that?
Oh, you're talking about the angle of the concave, the
Yeah, I
3/4
believe
inch
that's what they're
pipe.
talking about.
Yeah, I've tried 90 degrees. It wasn't, the coupling was too loose. And I know where you're getting it. It's your Tesla coils tend to do good with a less coupling. So for example, when you want a transformer that is very efficient, you'll wrap the primary coil really close to the secondary coil, as close as you can get, because that equals efficiency, but not with the Tesla coil. Tesla coil says, hey, if you try to get too close for efficiency, then you're not going to let coil 2 really do its thing and resonate. So yeah, I did try 90 degrees. This sort of 45 degrees has worked the best so far. So I'm good with it. But thank you. I have tried that.
Okay, let's see. Use the lamp as the coil base.
The lamp is a coil.
You lit it up. I remember that. You hit it with that little Tesla coil and lit it up.
Yeah, the LED light bulb, the big one.
Yeah.
Yeah, that's when it's turned off. So I wanted to let you know that what it does is it never turns off, even though you turn it off. And when it's plugged in, and what it gives out is 115 volts, whatever's in your wall. But it's microamps. It's so tiny. I mean, you're talking about micro is a millionth of an amp. Milli is 1,000th. Yeah, so it's very small current, so it's not that dangerous.
Very good. There you go. There's some more applause for you, Sean.
Thank you, Brandon. Appreciate it.
So they're asking about switching.
Yes, Myke. 3 on, 3 off. 3 on, 3 off. Yes, and if you don't have dialed in variables, so with the 2 transistor or 2 MOSFET ZVS, things can kind of, the coil around the pipe can kind of jiggle. Things can be a little loose, not so with the 6 MOSFETs. So you'll notice I put those plastic braces to keep the exact space between each piping. Otherwise, I won't get the 3 on, 3 off. Good question. Thanks.
Sequential?
Sequential is what you mean?
I don't know if it's a prior conversation or has to do with what you're doing there.
So the MOSFETs don't fire sequentially. They fire in 3s. So 3 fires while the other 3 don't. Then it's reversed, and then it goes back and forth 185 kilohertz. So it's not sequential. It's I would say it's parallel. 3 in parallel on, 3 in parallel off, and so on. And they're hooked in parallel so you can get the more current, the extra amps.
There you go, Sean. Beautiful work.
Thank you, Brandon. I appreciate that. I appreciate you guys taking time out of your schedules and letting us share with you.
So let's see. 3 are on at the same time and the other 3 resting and heating the amp. So it basically cools itself by doing that. Is that?
Yeah, that's one of the efficiencies of the ZVS, is that it's very efficient in turning off the MOSFETs. They're fully turned off. So that keeps them cooler. If you're having a looser switching, then the MOSFETs don't get that full turning off. which is good for heat. If you turn it off 185,000 hertz a second, that's going to add up to some efficient switching.
Very good. Ben says hello. He'll be here soon.
Awesome, Ben. Good to see you.
Let's see. There's Gerald. Gerald, where are you?
Hey, Gerald. Good to see you. Were you able to sit for my presentation?
Yeah, it looks like he caught most of it. Let me make
Awesome.
sure he has the stream ID. Let me pull up another question for you first.
Sure.
Okay. Okay.
Oh.
Go ahead.
So 1500 watts, not a chance. Maybe 50 to 100 watts with those transistors. They are the IRFP 260s I don't remember the rating exactly, but it's roughly around 300 volts, just something around there, and 20 amps. That's just a guess. I don't have the specs in front of me. But I think the 1500 watts you might be mentioning is the stereo receiver that I got at the thrift store. That was 1500 watts. And that's where I found that toroid power transformer, which is like pure gold. Does that answer your question, Anthony?
Let's see. Give me 1 second.
Oh, good question. Why use pipe versus wire? So when you're working with high frequencies, and you probably already know this, but the electricity, the electrons, they don't go through the wire. They go on the surface of the wire. So if you're running high frequencies, if you use pipe, it's like perfectly set, efficient for the high frequencies to run on it. And they call that the skin effect. It runs on the skin of the conductor, not the center. I could use Litz wire. I'm actually going to do some Litz wire on one of my other projects. And basically Litz wire, you probably already know this too, is where you can get 50, 100 enamel coated wires and you twist them. You've seen it on the BeneficenceTV channel where they stretch out that wire and use the drill to twist it. That's Litz wire. I can use Litz wire instead of the copper pipe, and I think it might be a little bit more efficient, but good point.
Here we go. We got another round of applause for you, Sean.
Oh, thank you. Thank you. You're too kind.
It's amazing work.
Thank you, Brandon. I'm having a blast with you guys.
Yeah, there we go. There's Crypto.
You're awesome, Crypto. You're awesome.
And I don't know why Mike put a little chicken there, but he might be talking to somebody else.
Thanks, Mike. Thanks, Crypto. I appreciate you. I have a blast.
Oscilloscope. So it's the oscilloscope. He just shortens it.
Oh, so ozone says the oscope? Is that a play on words?
Yeah, it might be.
It's funny. Yeah. Oh, so ozone says the oscope. Say that 6 times.
Nope. No, thank you. Winter weather comments. Yeah, that's me.
Oh, in Australia. Yeah, hot rod handheld Tesla coil. Love it. And that's why I showed the first slide where $32 you can order that thing. If you were to buy just those evacuated tubes, they'd run you up to $20 a piece. So the fact you get 4 or 5 of them, that's worth it. You don't even need the cool handheld Tesla coil, but it's just a really nice package and just a few modifications and you're off electrocuting everything in your house.
You know what, Sean?
Yes.
I'm going to do a video on that and show it on Wednesday. So you see all the stuff behind me, or maybe you don't. We're going to have some fun. Okay, let's just put it that way. So, for those of you who don't know, Sean sent me one of these, and we didn't go over how to put it together, and it's so simple. you know what I mean? We should have done it a while back, but it'll give me a chance to do it on video and then just start electrocuting everything in my garage. I got Tesla coils behind me. I got my gravity flyer behind me. I got all kinds of stuff laying around. So I'm going to find a ton of stuff to electrocute in my garage. I'm going to have so much fun.
I took a bucket of all my mismatched screws and washers and just spread it all out on my work table. And I was just seeing where the circuit would go. And it would just go to different places. And you're like, oh, this is so cool. It's just, I know it's silly for some people. But it's right up there with fireworks or setting things on fire. Electrocuting things is up there on my list of fun.
Nice. All right, here we go. There you go, Sean.
Nice goal. Thanks, Elijah Tech.
Huh.
Yes.
Yeah.
Yes, sir.
We're all having a good time, man.
Hey, not sure.
There you go.
Is it not volts that hurt? It's the amperage. Oh boy, that's a big number. Is that 1,000,000 volts at zero? Almost, yeah. Amps is just 1 watt. Yeah, your math is right. If you have the right number of zeros. So people say the current will kill you. Others say the voltage will kill you. When I was in the Navy, I had to take a test every year regarding my electrical engineering skills. There's more of a field of electronics engineer skills. And one of the things that I had to memorize was anything over 30 volts and 300 milliamps, sorry, 30 volts, 300 milliamps. Anything higher than that is dangerous. And to be on the safe side, the military always goes lower to be just extra safe. They call that being sailor proof. We would call it dummy proof. So yeah, it was 3 and 3, 30 volts, 300 milliamps. Anything above that, it can cause you damage and even kill you.
Yeah, no, thank you. All right. Probably work for ants too. Yeah, that definitely would.
Yeah. If I found an ant hill that's crawling in my house, I'm going to say, sorry, guys.
No go.
Yeah, that would be
Don't crawl across this table either. He's going to get you.
Yes.
Oh, man. First, that's going to look like a ceramic lamp, though.
So good insulator.
Oh,
That's
man.
funny.
All right, man. Gerald's here with us. We're going to bring Gerald in when he's ready. So
awesome.
I'm never ready.
Never. You're always ready.
How are you guys?
Good. How are you?
I'm alive.
Hi, Gerald.
Good thing. How are you, Sean?
Good to see you.
I've been trying to catch up on your presentation. I got here late, and I was catching. I caught quite a bit of it, but not all of it, so I apologize. But what I caught, awesome job, man.
Thank you.
Yeah, go ahead.
I was going to say, how many people here on the chat are wanting to get one of these handheld Tesla coils? Okay, Gerald raises his hand.
Yeah, I have one.
Yeah.
Nice.
Dude, Gerald, I told him next Wednesday we're going to light up things in my garage with this little mini Tesla coil. So it's already here. I have the package. We're going to get it open. We're going to build it. And then we're going to start zapping things.
Nice. Tomorrow I might be a little late. I gotta go out of town and help a friend move a tractor and finish the outdoor experiment from the barn to the tree. I told you about that previous. So it's an atmospheric energy collection experiment.
Wow.
Yeah. So I have 240 cable. It's good for 200 amps, and it's going from a 60-foot barn to a 60-foot tree, and they're insulated from both. And then in the middle, it's bare, and it comes down and it goes through my coil, and then it's grounded. So we'll see what happens. Maybe nothing. Maybe something.
So you definitely have enough conductor there to get some power from the Earth's electrostatic field.
Yep.
And so, yeah, that sounds interesting, though, to go
I'm
through
gonna
your coil.
push it a little bit with the coil. I found out something. Nathan kind of gave me an idea. I'm doing some testing lately, so I don't want to let the full cat out of the bag, but let's just say when you put the right size cable through the right size vortex coil, you pulse it at the right rate, it gives the power going through that wire just a boost.
Wow, that's awesome.
See what happens when you talk to the old man over here? Something always crazy is going to happen.
Old man builds.
And you got to know what's going to light something up, or else I probably wouldn't have thought of it.
Yeah. Find out. That's the way to go, man.
That's right.
Awesome. Are you going to put any measuring devices on your coil to see what it's doing?
Oh, yeah. I'm going to have an oscilloscope. I got 6 meters that I'm going to be using. I'm using my infrared camera and my infrared laser. So we're going to see if there's anything happening. We're going to see it.
Nice.
Yeah, that's awesome.
And if nothing happens, well, you know, I'll be a little late for fun, I guess.
Sure.
Let's hope you make it out of there with about stuff you're doing.
I agree with you, Tammy.
I've watched lots of theories and tons of video on Ed Leedskalnin and the pyramids, and I have a theory on how they might have floated rocks. My buddy has it's actually 2.8 tons, and it's sitting in his yard. It's this massive rock, and he's allowing me to drill it and then set up the experiment. So that I'll do, and I can't do it live, unfortunately, because it's in the country, but I can record it. And if it does float, we'll see what happens. It may not. Nothing may happen at all, right? But
if it does float, you'll float it right to the bank because it'll be a great invention.
Yeah, no kidding.
Maybe.
Yeah.
Maybe. But my buddy just wants me to get it out of his yard. So we'll get it on video and I'll move it to where he wants. And
awesome.
If it works, right?
Yeah, watch. As soon as it starts working, it's not leaving his property at that point. He's like, nope, we got floating rocks here. I just made $1 million. Leave me alone.
Just leave it there.
Yeah.
Build a deck on it so it just sits, right?
Nice.
Yeah, that would be sweet. But if I can float that thing with this theory, I have a rock that's like about 15 tons, and it's sitting in the center of an old limestone quarry.
Wow.
And there's a museum off to the left. So, and it's all in the same quarry, and I'm gonna walk over and see what I can do about making that sucker lift.
Wow.
Don't know if it's possible. Again, it's all theory at this point, but we'll see. I love testing this stuff because a failure is not a failure. It's just you moving forward in another direction.
It's there's a saying: experience is the best school, but few can pay the tuition.
Yeah.
I always look at us as a kind of in the 1840s they had the gold rush in California, the 49ers. That's where they got their name, and a lot of guys thought they were going to get rich quick, but they gave up. But the guys that stuck with it, they're the ones that hit the gold. And I kind of have that sense with the people in the chat and the people that are on these calls. We're staying with it. There's that vein of gold, and we're enjoying the process.
It's there. There's Nathan was saying it on a previous video. I think it was Friday after I had left, where we're all doing the same thing. There's one underlying principle in every system, and this won't work unless that underlying principle is in there. You can have 1,000 different types of coils. That doesn't make a lick of difference. But if the principle's there, in every one of those coils, regardless of how they look, it's going to work.
Right.
Just like your Tesla sphere. I love that thing. It's beautiful.
Thank you. Appreciate it.
I'd love to meet with you one day and see if we can make that sucker float inside of a bigger vortex coil. Because
That
what
would be
that does,
amazing.
oh, yeah, I'd have a lot of fun.
Huh.
Well,
One second, I gotta shut the camera off here. Thank you.
do you?
Oh.
Oh, you need the minute off. Okay. I was thinking that maybe making a miniature version of the coil and send you the 3D print files, and you can do your master coiling on it. Do you have a 3D printer, Gerald?
I'm working on it. I'm
Okay.
saving my money, so I'm working on it.
Well, just if you're interested, then I'll make a small one and send it to you.
Sure. We can work that out after the show. We won't do it, of course, now, but yeah.
That
That'd
sounds
be awesome.
good. Yeah,
Yeah.
sounds good.
I'm going to grab some really quick.
We're all going to start having fun now.
Yeah. Let's see some things levitate.
Yeah, well, we're getting there. You know what I mean? We're getting the right signs. And I try to tell people, and I don't think they understand it. We're not here to build the box. We're here to build outside of it.
Right.
And that's why it's the Fringe think tank. We're going outside the normal bounds of everything. So whatever you thought the shape had to be, just remember it doesn't have to be that shape anymore.
Yeah.
I live outside the box, so yeah, I understand.
Yeah. Oh wow.
So this is a bunch of my other little coils that I've worked on, all different ones.
Wow, amazing.
And I think that this one right here is the one that would be perfect for your spherical Tesla coil.
What's the diameter of that? What's the inner diameter?
Well, I don't think that this coil specifically would be it, but the actual geometry of the coil would be it.
I see.
So it would have to be in a bigger diameter, but I'm not sure if you can see the inside. It's layered. It's like a inverse double field coil.
Wow.
Yeah, I was doing some tests with that, and I think your sphere, that's the one for that coil. So there could be a little bit of a shot. That's just some of the small ones. I've got a bunch of others. I found my box. I'm going to pull them all out for Wednesday. So.
Very nice. They look like golden donuts.
Oh, gold. It's funny you bring that up. I have something on the way.
What?
I'm working on something big. I had mentioned it to Nathan, but I haven't said what. But gold is definitely part of it.
Awesome. Can't wait.
Yeah.
Very cool. Thanks for sharing. You're an expert.
Thank you for allowing me to share. You guys are awesome. Kidding? That's what this is about. Let's get it out there.
Right, exactly.
The more people that start experimenting on this, the better, right?
Yeah. Are you going to give us the secret sauce soon?
I will. I will. Actually, I gotta make sure that not giving away too soon, right? I just dumped a whole bunch of stuff over there, but I'm sure the cat will make it.
Too late. I already screenshotted it. Too late.
There you go.
I'm just kidding.
There's part of the secret sauce on this board. I was doing some crazy stuff today just to see if the circuits of old still work. And they do. It's all repeatable. Anyone that has the circuit with the coil, it's repeatable.
Nice.
I built a new coil that was similar geometry, but not the same amount of windings, and it acts the same way. So,
interesting.
Yeah, I'm using different elements now.
Nice.
Yeah. A little bit of silver, a little bit of gold, a little bit of, you'll see.
Yeah.
Yeah. I've always wanted to do it in different colors. Like Nathan had done with his coil. Beautiful job, by the way, Nathan.
Here you go.
Gorgeous.
Very nice.
My only issue and you even said it in your video, I didn't want it to look like a Christmas tree. Right? Like, I didn't want it to look like your Christmas wreath, right?
Yeah. I'm going to put it on my door.
That's what
there you go.
Christmas time, that's going up. We're going to put some lights on the outside.
Run a little current through it.
Yeah, some beautiful art right there.
The only problem is no two layers were resonant to each other.
Oh, wow.
So it complete bust. So, and it's just all about how you made it, right?
Yeah.
And I realized as soon as I was done, as soon
Mm.
as I checked the capacitance of it, I knew I was wrong
Yeah.
immediately. Now I just had to search for the flaw. So I have a giant pile of wire behind me that's on the floor because I winded and winded and winded until I could figure out which one is going to become resonant to each other.
Nice.
So I'm going to do it. I'm going to have a couple of coils that are just completely the same as one another. And then I'm going to put it on my Slayer exciter circuit. And
oh, wow.
I'm going to see this thing light up. I'm going to light some more stuff up.
You said I
Nice.
wasn't allowed to tell you secrets, so I'm not gonna. I'm gonna let you find out. If you get stuck, I'll help you along. But I'm not
There's
gonna
only-
tell you the beginning. You're doing awesome. I don't need to tell you anything. You know what I mean? It's
The
great.
whole problem is I don't want to wrap it around the peg. You know what I mean?
Yeah.
So in order to, when I was trying to flip it, I was wrapping the peg and I didn't like that because it would create the loop. And I don't know that I want the loop. So I have to find a different way to do it. So I didn't think a loop was in your system at all.
You don't want to loop.
Yeah.
Yeah.
Because that would be two across the field and that would be bad.
Yeah, it would cancel out the field previous to it, and then that would cause a cascade, right?
Yeah. So
Like I said, there's very specific things that even Jeremiah, once he wound a Star Chalice coil for Mike Powers. I just showed it to you. I have it there. But once he wound that one, he tried to wind a coil that was somewhat like mine, but he kept running into a brick wall because there's a couple of tricks that took me a lot to find out. Like I said, 178 coils at this point.
Wow.
And because of those tricks that he didn't know, he couldn't get that resonant flow, right? You're close, but you're not quite there. I'm not going to let you waste a lot of copper, though, either.
So thanks.
Right? Go ahead.
Sorry.
No, go ahead, Sean.
There's a book by Malcolm Gladwell, and the title is Outliers. And what he does is he researches how what's an expert, and the basic his basic thesis is that anybody who puts 10,000 hours into something, they are an expert. And I was thinking about that because when I look at your coils, there's some expertise in those coils. They're not just a pile of wire in circles. And so it looks like you've put in that 10,000 hours because you're an expert.
I've been working on this since 2007 or 8.
Wow.
Yeah.
So Sean, let me trip you out, okay?
Okay.
So this is what we're getting about when we talk about shapes.
Mm-hmm.
If I can take this shape here
Mm-hmm.
and I can add this green wire and this green wire together, and then I can add this red wire and this wire together,
Mm-hmm.
I can make that a Tesla coil.
Yes,
Now, if this wire here was the same amount as the other red wire,
mm-hmm.
I can make them resonant to each other and make a Tesla coil.
Mm-hmm.
So when you understand that all you need is the same amount of wire, and it doesn't matter how it's wound, you can get a Tesla coil. Now, if you want special features, it matters a real lot how it's wound, because it won't work with each other because fields cancel out.
Right.
So that's what we're talking about when we say we can change things on how they look and how you understand something.
Right.
So when I look at the rodent coil, I can tell you right now, I could probably treat that thing as a Tesla coil. All I need is the two windings to be equal to each other. And then I have to watch the crossing fields.
Yeah.
So, but at low power with that little Tesla thing you showed that we're going to build, I can put it through that coil with that. You know what I mean?
Yeah,
I will really get some numbers.
It's an oscillating output. So instead of a ZVS, you could use the handheld, and you'll get what is it called? I'm sorry, oscillator. You'll have an oscillator to hook up to
Exactly.
your primary and secondary coil.
I don't know about the Rodin coil, their output being like, I've watched all the videos and I've seen almost everything that Rodin put out, Daniel Nunes, and the other person that was working with them. I can't remember his name. It was for like 2 years after Rodin kind of sort of disappeared. But most of the times when they get their power out, it's multiple Rodin coils racked together in series. So it's like they're increasing their magnetic field in order to pull out more power, which is awesome. It just creates more space, more copper, more, you know what I mean? I don't know. Maybe I'm wrong, and I've been corrected, and I'll correct me. I'll definitely admit to it, right? But I'm not sure Rodin coils are the way to go. If they are, maybe I'll shove one in the middle of one of my coils. I don't know. But I'm not. I don't think they have the same kind of output that's needed. I think they have a function. I'm just not sure what function it is. Yeah, Ben said Randy Powell. That's the guy.
Yeah.
For about 2 years after Daniel Nunes dropped out of the scene, Randy Powell was everywhere. He was doing seminars and teaching about baby coil. So,
well, Ben gave us a presentation that he was reaching unity and above unity with his Rodin coil. I'm not sure. Is Ben part of the chat here, or?
Yeah, he's in the chat right now. He's trying to get home, but it's just slow going.
He'll be on.
Awesome. So, Gerald.
Yeah.
What was the reason why you started coiling, and what's your favorite coil?
My favorite coil. My favorite coil is the big one that you see me working on all the time, or working with, like the one with all the different pickup coils on the outside. It's my favorite because of the way that I got the numbers for it, and that was in a dream. Now, take it with a grain of salt, take it with a truck of salt. This dream was a dream of Jesus Christ coming to me, giving me very specific numbers. I made the coil, and ever since, I've been finding anomalies that I can't explain. So when I went to the scientific community to discuss what I had, it wasn't to show that I had something special. It was to try and understand what it was I was seeing, and to try and figure out whether or not I'm wasting my time. But it turns out there's maybe 3 or 4 different major theories that come together to make this system work. And there's 7 instabilities, and it does 4 major functions, 2 of which I can't talk about on YouTube.
Okay. No worries.
Excuse me. So, but these systems, they're based in sacred geometry. Even Nathan had brought it up in one of his videos. He was talking about Mandela's, and I had mentioned this before. It's one of the reasons why I asked Hans Dietrich if he had seen a coil like that somewhere around the pyramid, because I'm wondering why it was this system was built the way it was given to me. Because it was given to me, and I just, the next day, it took me 8.5 hours, I think, to wind it. I'd have to look at my notes, But, sorry, go ahead.
No, I had a similar experience where I'm not a writer, but I just felt this urge to write, and it was like a 5-page poem, short story.
Nice.
And there's a book called Pragmatic Thinking and Learning, and it's an expert where he uses computer terms to how the brain works. And so he'll say something like the brain is the CPU, our memory is the hard drive. But one thing that stuck out to me was, have you ever tried to think of a name of, let's say, a song, and you know it, but it's on the tip of your tongue, but you can't remember it? and you're in a conversation, and so then like 2
I've
days
done it with
later,
Nathan.
yeah, and 2 days later it pops up, and the guy postulates that our brains want to problem solve. So if we put something in our conscious mind, it goes into the unconscious mind as sort of a asynchronous process, like how a computer can work, and then it'll spit out the answer somehow in a day, in a dream. And it's interesting that that part of the brain is the part that spits out the answers.
And you know what? I would 100% agree with you. But there's a lot more to my story that goes to that I don't really talk about too much. It has to go with me dying. It has to go with what I saw after I died.
Sure.
When I came back, being directed to go to British Columbia, the stuff that I was involved in, the stuff I saw, it's a very long story. I'm in the process of writing a book about it. But
wow.
It's not just one dream. It's my life's been crazy. And then there's people that can testify to it. It's not like I'm trying to prove anything. Yeah. I actually set out to try and prove the opposite. And I've had my head kicked in multiple times for trying to do that. So I'm just saying, like in my life, that's how it's been.
Well, metaphysical is important. There's a spiritual side. I wouldn't want to neglect that. So I appreciate you sharing that, because there's the physical and then there's the metaphysical. And so, and I've met people who have experiences like that. I would never discount them.
Oh no, that's all good. And I don't diss on anyone that doesn't believe me. My beliefs don't require them to. I try and live by something since all that happened called Verticos Veritas, which is speak the truth is a way of life. Because after seeing what comes after death, I want to have a clean slate.
Yeah.
At least to the best of my ability. Hey man, I mess up all the time. I'm far from perfect. But yeah, I believe personally that there's a lot more to life than we see or even know. Maybe I'm wrong. I don't know.
I would wholeheartedly agree with you. Anthony had a question. How do I get the MOSFET, or I'm sorry, how do I get the ZVS to oscillate? Like, how do I get the signal to oscillate?
That's a good question.
Yeah. So if you think about the ZVS coil with just a capacitor and a coil, that's enough to have what is called a tank circuit. And based upon the coil's value and the capacitor value, that will determine the frequency that they'll operate at. So if you go up in capacitance, frequency goes down. If it goes up in the coil inductance, the frequency goes down, and vice versa. And so I hope that answers your question, Anthony.
Yeah, like a bucket, right? If your capacitance is high, then it's a bigger bucket. Whereas if your capacitance is low, it's like a small bucket, fills up quick and dumps quick. Is that right?
Yes, that's a good analogy, because the faster the frequency, the smallest amount is in the bucket for the capacitor. Capacitors will turn into a short at a certain frequency, because that's a good analogy. Thank you.
One other thing I just want to throw in here just for you guys. You have to look at what you're putting in your Tesla coil. If you put something down the throat of your Tesla coil, it's going to operate differently. So you can actually change some of the amount of wire. So by putting something down there, it'll seem like you added more wire to it, even though you didn't. So when you're building stacked coils, you have to keep that in mind, because you will change the complete capacitance of the whole thing by changing the design. So just so you know that, I already know that little bit, because you know me and my Tesla coil. I like to play around and hook up my gravity flyer to it. So it's funny when the light's next to the Tesla coil and it doesn't go off. Then you get to the top 4 inches where I put the wire, it goes off perfectly.
Wow.
I changed the complete capacitance of the entire coil in that top 4 inches.
Interesting.
So just so you know that when we do Gerald's winding, that thing has to be dead on accurate, and it matters.
And it changes when you change the capacitance, of course, changes the frequency, right?
Right.
So everything matters when you're adding it to the system. If I had 12 pickup coils on the outside, that changes the frequency, plus pickup coils on the inner core, that changes the frequency. It's all relevant to resonance, right?
Right.
Just like the Tesla coil resonating all the time. That wire going down the middle, only one I've ever seen do that is Nathan.
Yeah.
And
Same.
I asked about that picture from Tesla a million times to everybody. He's got this pole that comes up the center of one of his big coils. And it looks like it's grounded out. And everybody's like, I don't know what it is. Nathan figured it out. So,
wow.
I mean, it's awesome.
Yeah, definitely.
It's, by the way, one of the reasons why eventually I'm going to be able to turn on a tuning fork just with my Tesla coil.
Yeah.
I'm going to shove a pipe down that Tesla coil hole, and I'm going to make that sucker the same value as that tuning fork and turn that thing on.
See, and I think that has something to do with it's part of the theory of raising stone off the ground. I wonder if it was some form of a Tesla coil, like through the stone itself, which created the pole, and then they used an onk, which is a tuning fork, to flip it. So,
interesting.
Yeah, Nathan's he's got a good theory going on there. I might be using parts of it. Sorry, Nathan, for the levitating of the stone, but we'll see. I'm going to use everything I can. Right? It's not my theory, but
it would
works. It's everybody's theory because I'll make sure everybody knows. It's not mine. I don't care, right? I just want to see it raise. Maybe give it a push.
Yeah. Keep us posted.
Definitely. It'll be on video.
Nice.
Yeah. So is Ben coming on? No, he had to wait till he got home. Yeah.
Ben's about 15 minutes away, and he's good.
Oh, yeah.
He'll be here. Yeah, he's been checking. He's been watching the chat and stuff as he goes.
Right.
What was that last question, Nathan?
I'm sorry. Oh, there was right here was just an article about using sound to influence electrons. And I will say this: you could take sound waves and trap high voltage in it, and you can move the high voltage up and down if you trap it in there. And it has to do with the way the sound is working. So just when you think you understand everything, understand that there's another level and that there's a reason why sound is movement. Okay. It's not necessarily frequency. Frequency is built in a different way. It's movement.
You know it. Sound moves energy. And when you create a form of an echo chamber with sound, you can contain the energy. And by containing the energy, you can build a bubble. And that bubble, well, we've talked about that before. You know where that goes. Yeah. So
it's an interesting theory.
Sound is important. Sound,
interesting.
Vibration is the energy. Light is the energy moving in and around the wire at a high frequency. And when you have those three components, there's a lot you can do with it.
Got a big thumbs up from Mission Control. Frequency is everything. The power of resonance is it seems endless. It's such a interesting phenomenon. It's a phenomenon that is everywhere.
Yep.
A lot of people don't understand it as well as they should.
Yeah.
We're going to, though, because it's really, I keep saying the only way to break gravity is to resonate something. And you're going to have to do it. No matter what you do, it's the key. It always has been. It's been written on every temple ever built. And all you have to do is be able to understand it to read it. And once you get past that, you can read it everywhere. I literally can't look at these things without seeing it.
Yep.
Interesting.
We used to joke, I'm not trying to bring people back to the Bible, but the term Bible, Bible, basic instructions before levitating everyone. I don't know, you know? So if we look at
that before.
If we look in ancient texts, I think all the answers are there. It's just our understanding to look at those texts and see the answer for what it is today is a little difficult, but we're working on it. We're going to get it all said and done.
Yeah.
Yeah. I believe that.
Well, it's going to blow people's mind when they find that out. Like, if I walked up to Sean with my coil and I just said, here, it's a Tesla coil, you'd tell me I'm full of it. And then you would have to hook your circuit up to it. And then you're going to tell me, oh my God, how did you do that? And then you're going to finally see the light. It's not what you think it is. It's everything that it's supposed to be, though.
Yep. Yeah.
Well, I don't know if I'd debate you and say it's not a Tesla coil, but.
Well, I had a few breakthroughs this week that, okay, so when you take two of the exact same coils and they're bifilar, 180 degrees out of phase. Sorry, first day with my new tongue. Pulse your primary on the one, and I'm picking up, and then I pulse the secondary on the second one, and they're sitting about 4 inches away from each other, and the coils are picking up the power, which shouldn't be possible in that sense. Right. So I put it on video. It's a kind of thing where the next test is to bury one coil and then pulse them where one's above ground, one's below, and see if I can influence the other coil.
So it does. And so do you know the name of the video that you recorded it? Is it on YouTube?
It's not. The very first 2 parts are on YouTube. It's called the Peace Core Transformer. And what you see is you'll see the first coil sitting in between these 3 pickup coils, 3 legs of pickup coils. And then what you don't see is the video I haven't uploaded yet. And it's 2 coils, one above, one below, and they're about 4 inches apart from each other. Maybe a little more, no, about 4 inches. And they're influencing each other without any, they shouldn't because of how close they are. Even though there's a ferrite core in between them, the way that the system's working, it should be canceling each other out. It's not. I'm getting more power out every time I pulse the top one and then I pulse the second one.
Is this it, Gerald?
That's part 1 and 2, yeah.
Awesome. Good find. Let's watch it if it's not too long.
Is that the one?
Oh, give me a second.
It's out today.
All right.
I put 2 videos out today.
I'm using a different camera.
Nope, that's not the one.
Update. No, my microphone.
That's
doesn't
old.
work
This
on
one
my,
looks cool.
other camera. Go figure.
Yeah, that's the Thane Hein
All
replica.
right. So this is the Thane Hein replica.
Okay, so that's not the one?
Nope, there's 2 new videos I put out today called the Peace Core.
Peace Core, you got it. Okay, give me 1 second. Just take me a minute to find it. Go ahead and talk. I'll look it up.
So Gerald, did you just get off work?
No, well, kind of. I'm right now in talks getting a 2-story building, commercial kitchen / front storefront. So I guess you can call it work. I was doing the paperwork and the schmoozing. So yeah, I guess it's work, right? I don't know. I'm used to working with a shovel, a hammer, a screwdriver. I love working with my hands, right? So I don't know the schmoozing work, but yeah.
Okay.
That's what I was doing today.
Awesome.
Yeah.
Nathan and I are both retired.
Yes. Well, I'm physically disabled, but I can do work maybe every second or third day, providing I don't throw my neck out or my back doesn't go out.
Oh,
So I'm contracting this building that was burned out, and it's like a challenge for me, right? So I'm gutting it, redoing it, and I'm putting a business in it for a specific type of native bread called bannock.
Oh, wow.
And yeah, so creating a business basically.
Well, you have to share when you get it up and running and share what your goods are and sounds interesting.
I'm going to be videoing the whole right from beginning to end, gutting it, putting it together, That way people could see my skills. I work a little slower these days. I'm not as young as I used to be.
Yeah, I know that
I get
feeling.
the job done, you know.
I'm older than you.
Oh, maybe. I don't mind being young.
I'm 54.
Oh, yeah, you got 4 years in on me. You're my elder. That's all good, though. I think we're all young at heart.
Yes. Well, when I get my video working, you'll find out that I have a face for radio. So just so you know.
I got one of those right here.
That's awesome.
Without my beard, I definitely got a face for radio.
I was told I'm okay on camera, just don't smile, and then you'll be okay. But I smile all the time, so yeah.
Smile? Are you kidding me? All mine are fake.
Oh my goodness. CGI.
That's why they call me Old Man Builds.
Yeah. There you go. Was it? I hope it wasn't from high voltage.
No.
I've got a few left. So yeah.
You look like a biker in your Old Man Builds, like head of the Hells Angels or something.
There you go. Just need that Harley. I got a Hardley working over here. So.
I have a room full of Hardleys.
Yeah. There you go.
There we go. Old Man Balds. Yeah, it's getting pretty thin.
Yeah.
My forehead grows every year.
That's good. I like that. Mine's on the way.
I got a 5 head.
Oh, yeah. Yeah, it is what it is, right?
Yeah, I mean, I can't control it, and I'm sure not going to do anything more than shave it off with pride later.
Yeah, I'm not going to be like my grandfather where he had 4 hairs and he just combed it over the head. Right? No, I'll just shave it and that's it.
He's got the Homer Simpson thing going on.
Yeah, yeah. Mine's getting close. Never mind, you know. I shave it permanently pretty soon. Yeah, it is what it is.
Yeah. Is this the video?
Yeah, it is. You ready?
Yeah.
Okay, here we go.
Peace. All right, everybody, I'll try and make this quick. This is a little demo of the Peace Core transformer. It's basically a Thane-Hein transformer with a 3rd leg and a vortex coil around the center. We're going to pulse it with 25 volts, 10,000 hertz, 1% duty cycle square wave, 20 volts per pulse. Each leg has 1 meter set up to it, except for this leg here. All it is looped with a wire. It's going to be pulsed with my bifilar circuit that I showed in a previous video. We're going to turn the primary on in 3, 2, 1. We're going to turn the secondary on in 3, 2, 1. As you can see, we got 108, 32, and 50. And that's all from 25 volt pulse between 1 watt and 0.1 watt. All right, everybody.
Wow.
You have a great day.
Yeah.
And the other one, I cover it with an aluminum canister that I'm working towards putting something else in. And the voltage goes up. So it contains the field that's within it.
There's so much going on in that build. Oh my goodness. It's just amazing. You're so creative.
Thank you. Took a long time to get there.
Yeah, you're 10,000 hours.
Yeah. Yeah. Or more, maybe. I don't know.
Probably.
Yeah. 10,000 shocks for sure, I'll tell you.
And 10,000 volts.
Yeah.
Same setup as the last.
There we go, guys. This is the second
I'm
one.
going to try and make this quick. Same setup as the last video, except, let's see if I can do this so you can see it this time. 25 volts input, same pulse rate. The 3 meters go to this coil, and this coil. This one's just on a closed loop. We'll get into that later, and I still have to wind this coil. And there's one in here I'm not going to wind. We'll get into that after. The point of this video is this. You've seen what it produces as is. let's see what it produces with this on top. Just a
Wow.
thought. All right. Primary turning on in 3, 2, 1. Secondary turning on in 3, 2, 1. Oh, a little bit more, right? So we got 115, 41, and 48. All because this aluminum is encasing it over. Is that just a glass plate? I guess we'll have to get into that in the future, won't we? You have a great day, everyone.
Gerald, are you bouncing that eddy current in there?
Bouncing and how?
Well, every time you put aluminum around and you got a magnetic field, you're going to bounce the aluminum a little bit.
Something like that.
Something like that, huh?
Yeah. Well, think of it like this. It's not just bouncing around inside the aluminum. What's it sitting on?
The glass plate?
Wasn't glass.
Somewhere there's a microwave missing that.
See?
Yeah, it's a
Sean's
microwave
like,
plate, but
okay, but
what
what's
is that made out of?
borosilicate?
Oh.
Mm.
That matters,
Okay.
right? So we got reflections going on of waves and
It's made for standing waves, microwaves.
Mm.
Interesting.
well, it's definitely part of it. I tried it without it, and I surrounded it just by aluminum. Didn't get the same effect. But I also didn't get the same effect with just the borosilicate. And then I have a Pyrex bowl that I put on top.
Wow.
Again, not the same effect. So
very interesting.
Yeah.
Yeah, that's
Very-
awesome.
Very good.
Hey, Ben, what's up? Nice to see you.
Good.
Glad you
What's
made it.
going on, everybody? Yeah,
Not
I'm
the
glad
same
I
without
made it too. Yeah, thanks, Sean, for your presentation. I caught it on the way home. I was listening. I didn't obviously watch it while driving, but I was listening, and very interesting stuff. And Gerald, your new take on De Glocka. It's kind of looks like the bell a little bit, so
A little bit.
it's awesome.
I'm making it's already in the process. I'm almost done. There's a structure holding a smaller coil up towards the top of the inside, and then one that fits perfect on the bottom of the bell, and they interact between the two. We're gonna see if we can get some sort of a bucking system going on that. Well, we all know what we're searching for, right?
I have exciting news to announce to everybody. Nathan, I don't know if we got Michael on for next week, but he did send me the coil frame 3D files for the new Vortex 432 Advanced version 3 coil, and it looks exactly like it. It could be what we're looking for.
Nice.
He did a really good job on it.
Very nice.
Just what I needed in my life. Another coil to wind and unwind and then rewind and then
And we
unwind. And rewind
and there's
again.
there's no guide for that one, winding that one. So we're gonna have to, do a little trial and error there.
More trial and error.
Yeah.
More Christmas wreaths.
Don't worry, Nathan. I'll do all the heavy lifting.
So
I can't wait to get into that one.
on a different subject, but one of the comments they said this, right? So just to tell you, a little bit of a brag, okay? I took dance class for 3 years, so
you know how busted move.
I'm not going on TikTok, right? I'm sorry, can't do it. Yeah, but yeah, I know how to dance a little bit.
Nice.
It's always good to know how to dance.
Damn straight.
Hey, real quick, Ben, did you see the little mini Tesla coil? Were you able to catch that in Sean's presentation?
So
I listened to it, but I wasn't able to see any of the video, unfortunately, yet.
You remember that last little Tesla coil he showed us lighting up the little board and it did the squares on it?
Yeah.
He walked through early in the presentation on exactly how to build it, and it was completely easy. Okay.
Yeah, I was listening to a little bit of it. It didn't seem too involved.
No, but the cool thing was is with your coil, Now you could take a little mini Tesla coil and just touch it on each wire and see what you get. So I'm absolutely fascinated to see what you do with it. So I think you should buy it. It's like what, $30, I think.
Yeah, see how the energy flows and everything. No, that would be great.
Touch it everywhere.
Great.
Yeah.
Oh, I love
It'll
that.
surprise you. It'll surprise you.
Ian's here.
Oh, there we go. We'll put him on as soon as he pops on there. There we go. Oh, he's got his setup up. You ready, Sean?
Ooh.
There we go.
Yep. Ready.
There we go.
Uh-oh.
We're in for a treat today.
Electricity. Sorry.
Did you guys know that he flies helicopters?
No filter. Just no filter, Gerald. Just
Like-
zero filter.
Yeah, sorry.
How you doing, Ian?
Good. Can you hear me okay?
Yep.
Yes.
We see your gorgeous work too.
Yeah, some nice equipment, a beautiful coil.
Yeah.
Wow.
Looks like your background, Ben.
Right.
I know, only real.
Right. Gerald, do you recognize any of this?
Nice.
Can you hear me okay?
Yeah.
Yes.
Can you guys hear me?
Yes.
We can hear you.
Loud and clear.
Oh, you can. Okay.
Like he's
All
got-
right, cool.
Yeah.
Yeah, this is
That's beautiful.
Yeah.
I know, I love it. It's so cool.
A copper bagel.
Nice.
It kind of looks like a UFO a little bit, the way
Yeah, a
it
little bit.
shines.
That was the one he showed us last week when he came on.
Yeah.
That coil. Now he's got something in the middle, some kind of pickup in there.
Yeah, the one
Yeah.
where he holds it up and it looks kind of like a Mandela.
Yeah.
It looks like he's got like a Tesla coil in the middle or some kind of helical coil.
Yeah, they look like maybe secondaries.
Pickups or something.
Mhm.
Yeah, Ian,
Yeah.
can you hear us? Ian,
Did you
you
guys-
there?
Ian?
it's simpler. It's simpler than that. Hey, it's simpler than that. Can you guys hear me?
Yes.
Yes.
Okay. Right. It's really right. It's really simple. It's really simple. Can you hear me?
Yes.
Yes.
Can you
Ian.
hear me?
Yes, Ian.
Can you hear us?
Oh yeah, that's a better question.
Oh yeah. Oh yeah. Okay.
Okay.
So that's okay. The setup is just the coil. This one. This is these are two pickup coils.
Are they
Yeah.
hollow pickup coils or ferrite?
Hey. Wow.
I think
I'm
we're
so
freezing.
delayed.
Thanks, Anthony. Did you guys know Ian is a helicopter pilot?
Wow.
He flies the
Wow.
biggest helicopter for medevac.
Nice.
Wow.
Yeah, he's very humble, but he's very smart.
Right on. No, we just got to get him to where the mic works properly.
maybe the electric bagel is interfering.
Maybe. Yeah.
But these systems, you never know. Honestly, you really don't.
Yeah, that's true.
He's got a lot working there.
He does.
Oh, here we go. He's talking to us on here.
You can't hear me. It's a huge delay. I don't know what's going on. Yes.
Hey, Ian.
Well, how about Ian?
I-
How about you just take a minute and just tell us what's going on and just explain it, and then we'll all be quiet.
there's a huge delay, it seems.
Ian, trace out your circuits. Help us go through them.
Okay. I'm gonna try and just talk here, so I can hear I can hear all of you. Okay. All right. Very, very, very simply, here's what's going on. There's a pulse is coming in here through the transistor. It's the 3055. These pickup coils are going to two rectifiers, full bridge rectifiers. One is they're ferrite, and so. But look, where do you see? What do you 1.3? Take them out, and it goes up. Go down in, and it comes down. But we're getting 112 and 56. Look. 0. Nothing. 0. Oh shit. Okay.
Oh, he just completely is gone.
He
Maybe
might have
it crashed it.
or something. Yeah. Did he say what the input power was?
I didn't catch it.
Something crashed.
Yeah, something crashed. I mean, the coil, if it's working, it could be interfering with his equipment. Who knows?
I don't know. Got a bunch going on, that's for sure. he told me he was making some fun with me. He's testing his Christmas trees too. So he's talking about his coils. So it was just funny. Yeah, he's been testing them all week. He's dropped me a few messages on it, and I was kind of excited to see what he did.
Yeah, it looks like a nice coil. I didn't catch his in and out though. Like he was talking about it, but there was so much delay.
Yeah, they'll probably reset his computer. Hopefully, he'll be on again. We'll have him back up.
Hopefully.
So, what did you think, Sean? You there?
He's muted.
Oh. He'll be back in like 10 minutes. Okay, so we got everybody has something going on.
Oh yeah.
So hold on one second.
Oh, there goes Ben. It's just us, Gerald. They left us in here alone. What were they thinking?
No.
I don't know.
I'm just wondering if he had something simple. I think he had something simple like this in the center, right? Just something simple.
Yeah, just a coil pickup. Yeah.
Yeah.
Just the solenoid coil with ferrite in the middle. I believe that's what he had.
Yeah.
That's what I should try too. But yeah, that was interesting. I'm interested to see his experiment there.
Yeah, ferrite seems to pick up on high frequency better than anything else. Like I got lots of coils from old adapters. They don't pick up as well as ferrite.
So you think I should, when I test this on the rodent coil, you think I should stick ferrite in the middle?
Try both. Try, like steel plates, like a transformer, and then try ferrite. Whatever.
Or I could also, and I could also try just the air coil too.
Yep. I think that Tesla knew that air core was the key to being able to attach it to other systems, and that's why he did what he did. He was a genius.
Yeah. He was way ahead of his time.
Heck yeah.
That's the thing, when you're ahead of your time, people they don't see what you see, and that's where we're at. We're on the precipice where we're ahead of the curve. You know, not most people are going to disagree with a lot of what we're saying, but
you know what? I would 10 years ago, I totally agree with you. Right now, the scientific community, I don't think it's directly because of us. I think it's because of a whole bunch of people.
Just everything.
Yeah, but they're starting to come around where they're beginning to think that energy, it's possible to get excess. It's not free because it takes energy to make energy, but getting more out than in, it's starting to actually enter into their mind. So if the scientific community would hurry up and catch up, we'd already be running our houses for free.
But that's refreshing to hear. Yeah.
Yeah. I think that theory can come after the system runs. Because what's theory going to get you? Sure, you might know where to look in the right direction if you have the right theory, if you have the right parameters around that theory. But if you're just experimenting and you happen upon something that works, isn't it proper experimentation to find the theory out after? I don't.
You have to formulate how it's doing what it's doing, and that.
Oh no, I get that. I can explain mine 5 ways from Sunday blindfold. That isn't it. But is that considered the theory behind it, or is that considered the mechanism of how it works? Do you know what I mean by that?
I guess it depends on the context, right?
Yeah, I guess before, if you were trying to engineer a system that would work, you would consider it theory. But if you had a system that worked and you were trying to figure out how it worked,
you just stumbled upon something and you don't know what you did.
I guess that's different.
So give me 1 second, guys. Ian said there's no magnetism because of the windings. Okay. No magnetism at all. Okay, that's what he was showing on the Tesla meter that he had out there. Then he's going to reinstall the drivers for his camera and try to get back with us. So right on, Ian. We're gonna look for that. So I wanted to go in there. By the way, when you have a community and you bring up something new and they have no idea what you're talking about, that's a bad sign. Okay. And when your paper is based on somebody else's work, but you didn't do the work, that's a big problem because you don't know the shortcomings of it. So you're trying to calculate something in there that may be completely wrong and doesn't work. It's a bad idea. You replicate it, then you can go on. Then you can tell the ins and outs of it. And if you're lucky, the inventor left notes and told you exactly why something didn't work. Rarely does that happen, but that's a lot of the problem in the scientific community. You cannot do that. You have to rebuild it to find out why. Now, the only case that I would say that you wouldn't do that is any kind of nuclear stuff or any crazy stuff like that. But if it's just something like a Tesla coil, if it's just something in a winding, dude, this is basic stuff we can all do. Well, I have troubles winding stuff, but that's beside the point. I'll get better at it. But you know what? I just think it's just something that they need to start doing again. And I'll be honest with you. Spend a couple days with me. Spend a couple days with Gerald and Ben. We're all good. Spend a couple days with Sean. You may not come out of there alive if he gets 1,000,000 volts, but generally you'd be okay if he didn't. But I'm just saying that's the kind of thing you need to do. You need this side of it. You need the experimental side of it, and without it, you're
a paper pusher.
Yeah, you might as well just throw rocks in a pond. You'd get further.
Yeah, I agree.
Hi, Jen.
Go ahead.
Hi, Jen. Sorry, needed a break. Sorry.
Well, understand.
Welcome back.
Thank you.
So we're all just talking about doing experiments here, Sean.
Sounds good. Who's first?
Oh, we're not presenting experiments.
I'm just talking about the great purpose behind it. That's how you find truth, is experimentation.
one of these guys, I'm just gonna bring up everything in my garage and have it ready for Monday. So when you two aren't here early, I'm just gonna light up my garage and do it for about 20 minutes. It'd probably be the most fun I've had in like the last few months.
Sounds good.
I can't show everything in my workshop. Be 8 hours. It's insane. That's why I said I wanted to do a presentation with APEC, and you would have got like a glimpse of what I have. I'm just going to do the presentation on your channel.
Well, I can tell you right now, there's not a day that goes by I don't get somebody asking about it.
You know what? I look at it like this. My dad always taught me, if you try for something, it fails or it doesn't happen, try again. Okay, so you really want it, try again. So if the second time it fails, it's try again. On the third time, if it fails, wasn't meant to be, get the heck out of there. Try something different, right? So
what ended up happening for APEC? I know you didn't get to present.
No, that one was on me. My back went out. I sent him a message. I didn't get a reply. I don't know if he even got the message because there's consistently interrupted messages between me and others. I'm the most shadow banned person there is. Oh, not to mention, you put out a short. It was at 453, dropped 100. I watched it happen. I was like, wow.
Wait, who?
On my channel.
Oh, on your channel?
Yeah.
Oh, wow.
Nathan and I, like, he was helping me with shorts. And it was at 452 or 3. I don't think it was 8. I think it was 2 or 3. And I literally watched it go down to 358, 353, somewhere in there.
Wow. That's not good.
Is what it is, man. When you're over the target, they want to push you away from it a little bit.
You're watching that in the studio, right? Not in
yeah, in studio. Yeah. I was I think I was uploading a video when that was happening, something like that.
Yeah, that's weird.
Yeah. Happens to me all the time.
But that's why you should also make a Rumble, you know, just to back up.
I tried. They won't email me back.
Really? Well, I'll make one for you. I'll give you access to
Rumble. Actually, you know what? It's the second. It's my time to try all the platforms again. I try every month. Instagram, TikTok, Rumble, Discord. You name it. I never get any emails back. It's like somebody sitting on my email going, nope, 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 nope.
Wow.
Whatever.
Hey, Gerald, I took some liberties with your little emblem.
Yeah,
so I want you to check out the upper corner right now. Take a look at that.
I like that. That's my angry face. I like that. That's good.
Very cool.
That should be on all my revenge videos. No, I'm kidding. But that's cool.
I couldn't get your other logo because it was blurry. So every time I go to put it on there, So I just go, you know what? Give me about 10 minutes. Let me work something up. So I said, you know what? Anyway, I sent it to you in case you wanted it. I sent it in your email.
I'll send you the gold one with the light behind it.
Nice. Yeah, send me the one you want so I can put it up for you.
I don't mind improvisation. Improvisation's the key to life, man. So it makes us smile.
Oh, what you got there, Ben? Hold on. Give me a second.
Something Ben. Levitating? What?
Nice.
He got a little levitator with some styrofoam.
A little acoustic levitator, yeah.
Wow.
Transducers. And
that's cool. That's just sound.
It's just sound. Look, it's floating in a node. It's caught in a little node in the center. Oh, my bad. It's caught in a little node. You can see it spinning around.
That is amazing.
And then I unplug it and it'll just fall.
That's
wow.
I told you, Sean, high voltage does the same thing.
Yeah, that's right.
You can hold it and move it.
Amazing.
That's awesome, Ben.
Yeah.
Yeah, these are very, very easy concepts if you know how to understand them, I guess.
You could take a transducer and take a piece of glass and put it over it, get the correct height, and it'll do the same thing.
Mhm.
Oh wow.
That's cool. Yeah, there's a lot of cool nifty things, but I think it all relates back to basic science and misunderstandings of different things.
Acoustic
Yeah, I don't think that
levitation.
science. Sorry, go ahead.
Acoustic levitation.
Mm-hmm. Yeah, I want to actually eventually build one that's parabolic, kind of like a half sphere on top and bottom. And then you can actually rotate the sound. And if you rotate at a specific frequency, the sound around, spin it with the object, you can lift a little bit bigger objects. So
Wow.
I'm interested in maybe doing a torsion, seeing if you can spin it one way on bottom and one way on top. So maybe that helps in some way to lift.
Say that one more time, Ben.
So, okay. So when you have a acoustic levitator like this is just a basic one with one on top and one on bottom, one speaker. But the more advanced ones can lift a little bit heavier objects, and they're like big parabolic, half circle shaped dishes on one. There's one on the bottom and one on the top. Yeah. So, and that's the advanced configuration. And the theory is you rotate the sound around in a specific frequency, right? A specific rate, and that allows you to lift a little bit more. I'm thinking maybe if you counter rotate on the top as well. I don't know. It's just something, but I'd like to play around with it for sure.
Counter rotation's a key.
You wonder why my gravity flyer has two spinning discs that come out with frequency like that and sound.
Yeah. You got to have that torsion field.
Yep.
Creates a magnetic field on the disc, and then you hit it with a pulse wave, and it makes a speaker. It's hilarious. All of it tied together.
Wow. Can you think you can rig it so when it flies, you can have it as like a working speaker as well, like where you can have like your music blasting through it?
You know what? It would have to be, but I don't think it's going to be a speaker in the sense where your music blasts through it. I think it's going to be like a ringing, a high pitched ringing, and as you're going by, people that are close to it will hear it.
Yeah.
Yeah.
That makes sense though. Yeah, put that sphere in the center of my rodent coil in a specific frequency, it starts ringing real loud.
Wow. Resonant frequency.
Yep.
Mm-hmm. Yeah, it'll start winding too. I have the video of the it was like those little disc shaped neodymium magnets, and they stack together to form like a long cylinder. I put a long cylinder in the center, and I slowly increased the frequency, and I heard the noise like winding up like. And then I let it sit there, and it just absorbed the energy.
Wow.
And then when I had one sphere, or I took one off, and then it snapped back together, and it like had so much energy in there. I guess it had that spark. So
wow.
Like I dropped it and.
Go ahead, Sean.
Oh, that was a really good presentation of the sound. It was realistic.
Yeah, my bad. That was a little too loud.
So, yeah, that was pretty loud. You got me there. Sorry. Hearing aids do funny things to you. Hey, take a look. This is Merkaba's machine.
So does Pepsi.
Yeah.
I just wanted to show you this. I was going back and forth with him, and we were talking about sound and frequency, and right there where it says coil on it, he wants to be able to pick up the frequency on each side of it. So he's looking for a device that can pick up frequency on there so that he can tell exactly what's going on and where's it at. But for those of you who don't know, in the center there in the blue, he has a neodymium magnet that he's spinning in there. Kind of like yours, Ben. and he's doing it with sound coils on each side. So
yeah, this is a new one. I haven't seen this rig yet.
Yeah, this is the new one he was doing. So
that's the Merkaba. Is that what it's called?
Merkaba.
Merkaba.
So this is the older one right here that we all saw last time. So here's the piece here he's working on, trying to get that thing better so that he can spin it. And he was just having trouble here. You can see it digging in.
Oh yeah,
yeah. Same thing. You see it in the plastic cup I have. It digs in.
So here, look at this new machine, man. Have you seen this before, Sean?
I haven't. Wow.
This is a lot more advanced than the other one.
Yeah.
This is cool.
Yep. Time to step it up a level, gentlemen.
Dude, and he built that fast.
Is it all sound? Is there any electromagnetic waves?
So check it out. Let me do my job and pause it if I can. And you'll see these black coils right here with all the colors coming out of them. Those are around the whole thing. And it's like a diamond and a diamond shape, or a square and a square, right?
Okay.
So a square going over the top and a square going around the outside. And that's what's running everything. And he's got pickup coils that he did on the last one. I don't see him here. But those coils will make that magnet rotate. And then he had a version where there was a pickup coil. So where the center parts come in, there's a coil on the outside right there that would just send out frequency.
Wow.
So he was creating an amazing machine here.
And the sphere is a neodymium sphere.
Yeah, give me a second. Let me see if there's more here. No, not that way. Oh. I'll have to pull it up. Oh, here we go. Now it's sliding. Now it's giving me what I want. Come on. He's getting the shape of a Merkaba in the center. Let me see if this is it. No, that's not it. When he turns it on. There it goes.
Wow. Is that sound or is that electricity?
That's his sound, and that's what it's doing. It's creating the sound in the center to spin everything. And as he turns each one of the sound things on, it makes a different turn.
Wow.
Yeah, this simulation is cool as hell.
Yeah.
So he's got different iterations of the center part, but it's all kind of the same machine.
It's 2 cubic forms turned 90 degrees.
Yeah.
Is the whole thing made of plastic?
So there's a metal frame. And then, like I said, the wires, they look black, but they're actually wires in there. They're just taped over. And yes, he printed a lot of stuff on there. 3D printed a lot of stuff.
Well, I could do so much of the printer.
That's a nice housing for the sphere now.
Yeah.
That's a nice containment unit.
That's what he originally thought was going on in there. For the magnetic field, that it turned out that it was doing the Merkaba thing. So I just thought it'd be interesting to show you that, Sean. I don't know if you saw it. I'm gonna switch this. Sorry, that one's yours. Let me get back to where I was. Sorry, guys. I actually wanted to show you the machine. So you guys go ahead and talk. Give me just a minute, and I will look it up.
We're getting some interesting comments.
Yeah, that's what I was reading. So go ahead and talk, but I'm like, I'm reading. Hang on, look at my glasses here. No, I'm just kidding.
So check this out. Let me see.
Acoustic fusion was the comment.
We have a really active chat tonight, fellas.
Yeah.
Oh, I can't wait till you see the next little thing I'm building.
This
Yeah.
is the live we did.
In theory, and they generate magnetic fields, but they're actually deep. And on each of the points, not on this version that you can see on the screen, but on the latest version, it has one on every one of these cross points where the intersections are, which again, the whole shape lends itself to this. But then there's fine wired coils on each of those 6 intersections. That's acting like the microphone, and they're literally just put through an audio amplifier. And as you start the ball spinning, I only switch one channel on, and then allow it to get up to a certain speed. It's a bit like driving a car. It feels like you're changing gears. So then when it gets to a higher speed, I turn the second one on, the third one on, etc. That on. And the way I like to think about it is it's the sound of the magnet, playing the sound of the magnet spinning, that makes it go faster. It's almost like hallelujah. It goes round, round. It can hear itself spinning. It's an audio feedback loop, but with electromagnetism involved, obviously.
So, just real quick, you put a coil where they meet on the corners. Is that what you were saying? So that it starts up the ball?
And what you have to do at the current build is you just get a magnet, you give the big ball in the middle, the ball near the spherical near a bit of a whip, and that little spin, and it always has to spin. If you look down, it has to spin clockwise. It won't spin anti-clockwise. Whether that's something to do with the wiring, the way I wired it up, I don't know. So once it starts spinning and the amplifier turned on, it takes a little bit of tune from the bass and treble and volume, and then it just starts spinning. And it doesn't want to stop.
So, do you see the coils now on the 4 corners on the inside?
I do.
Yes.
Okay. So he's got the outside winding, and then he's got the coils on the inside. So he's getting a spin out of it. I just thought it was one of the most interesting machines I've ever seen.
Yeah.
So
Yeah, that's gorgeous.
I wanted to bring back Ian since he made it back.
Nice.
So give me 1 second. Let me stop presenting here. And
Oh, there he is.
Ian, can you hear us?
Yeah, can you hear me?
Yep, a lot better now.
Yeah. Okay. Is there a 2-minute delay anymore, or are we okay?
This sounds good.
Looks like it's okay.
Yeah.
Okay. All right. Oh, there it is. All right. Oh, look, there I am. Whoa. All right.
Oh, it's still
Okay.
delayed.
What I was trying, I think the cable I had for my camera, maybe it wasn't a USB 3 cable or something, but that's maybe what was screwing up all the sound and everything. But here we are. Okay, so basically what I was trying to show, I tuned the coil with that circuit that you gave, the positive pulse circuit, Gerald, on Wednesday, using the 3055, the NPN transistor, and I basically found that a useful, these aren't the best waves. I can get a nice clean one, but it doesn't produce any power in the pickups. But also at 78 kilohertz and 10% duty, any more duty than that, it didn't achieve anything. So I just left it there, and if I went down, it reduced it. So I just put it to the minimum active duty cycle. The input voltage is I've just got, it's arbitrary. It's 18 volts, and
Okay.
and it's about 3 watts. So it's 178 milliamps is the input. So you're looking at 3 watts input from the DC power supply. Whenever I put these, this one is a thicker one than this. I just made this today to see if a second one would actually work without loading the coil, but I can't find any magnetism anywhere at all. And I think that's because I did the 180 turns and canceled it all out. But I'm still getting a and I've got an analog ammeter here going to after the rectifier into the cap basically, and I've grounded the cap as well just to see, and it raises the voltage a couple of volts, but nothing really. And if I take the cap off, it's just that it goes instantly to the voltage that it reads through the cap. I was just using the caps to make sure that there was something moving somehow, somewhere. And the only amperage is coming out of the power supply. There's none here. I can't measure any on my on this. I can't measure any on the clamp. Well, I do, but it's completely erroneous. And so the main thing was that, what do you say? So you've got 3.2 watts there, right? It's higher than it was earlier. I don't know why, but if I take these out, see what happens? The watts goes up, not down. When I put them in, the watts go down. And we're getting 113 volts on this one. And I mean, they work anywhere inside. Now we're getting 68 volts on this one, the one beside it, basically for nothing. So I thought that was interesting because there's real power in these. When I discharge the caps, there's a huge spark. So there's energy in there. There's energy coming from somewhere, but I don't really understand where. But as I said, there's no magnetism. There's a pulse. I can take this up, and you can see the voltage will go up with an increase in voltage, but obviously the watts go up as well. But look, there's 170. But if I go any higher than that, then it overheats the transistor. So I mean, I can leave it at 24. There we go. So you got 100. It's stabilizing down. It's just the capacitor got a bit of a charge there, so it's running it down a little bit to its nominal, whatever it's doing there. So yeah, I just thought, I've never seen that before. I've never seen getting voltage. I've got 100 there, I've got 140 there. I've got 4.5 watts here, and when I take them out, I've got 4.6 watts to run without them, and when I put them in, the watts go down.
Wow.
Very little, but it's the fact that there's nothing inductively happening here at all. So I'm asking,
that's crazy.
Where is the energy coming from? That's what I'm. Because it's the same as I saw with yours, Gerald, when you were putting your pickups in, and it was having no effect on the actual feed from the power supply. And in this case, it's actually going down a little bit.
Looks like you've obtained charge compression.
What's the diameter and gauge of the wire you used on the coils as well as on the donut?
These are 20 gauge, and these are, I mean, this was one I had lying around, and that one I just made today. But this one is giving them a higher voltage than this. It's about 50 volts more because the wire is wound directly on the. I'll show you. They're like these.
Oh, ferrite
like
rod.
They're just antenna. What do you call them? Rods. So
Ferrite.
So ferrite. Thank you. So, but today then I made some formers like this to make some more, but that's not directly on the ferrite. There's about a 1 millimeter of PETG there from the printing. So that's why that one is giving a different reading to that. But no matter where I move this one, anywhere in the donut, the reading stays pretty much exactly the same. It doesn't change. So as many of these as I can fit in the hole here, they're right beside each other, and it's not affecting anything at all. So so when you say charge compression, Gerald, what exactly do you mean?
Well, it's like you've managed to do the similar thing that I've done in the middle. You've focused all your electron flow to the center of your coil, and at high frequency, they just love to have ferrite there because it absorbs them, and that's how you're able to pick up that excess voltage. Have you put a load on any of those two pickup coils? You may not get much out.
Just the capacitors.
That was the question I wanted to ask you.
10
Your
microfarad.
capacitor, when you short it out, is it a green color that comes off the spark?
I haven't noticed. Shall I do that? I might as well.
Definitely try that. If it's a green spark, it means that you're filling it up with a different type of energy. At least that's what I've noticed.
Ooh.
Okay. You see it?
Yeah.
Try not to electrocute myself.
Saw
It's
it.
kind of a purplish.
Yeah. Purplish white.
Did you see it?
Yeah,
Yeah,
we saw it.
white.
How many volts was that?
That one had 100 and I've disconnected it. That had about 140 volts. But
Ian,
I mean, it's a 1300 volt DC capacitor, so 10 microfarad.
Ian,
So,
if you're using a DC power supply, what are the bridge rectifiers for?
it's to convert the AC oscillations inside the pickup coils and actually make them useful into DC, just to measure them on the meters.
That makes sense. Okay.
But the strange part
Yeah.
is you can't pick up AC. Like, I don't know if you're going through the same thing that I am, but when you're using a pickup coil to pick it up, you switch your meter to AC. You would think, okay, it's going through a full wave bridge rectifier, so you're getting an AC signal and you're collecting it as a DC signal on the back end of the full wave bridge rectifier. But when you test for AC, you don't see it.
Right.
I don't know if that.
Yeah.
There's
No,
resistor
I
or
don't
anything to test it.
Yeah, that's true. Even with a capacitor, there's a small form of internal resistance, though.
There's a drop on the capacitors. That's correct.
Yeah.
So what are the watts in, watts out, Ian?
Well, I can't measure any current, so I have no idea what the watts out are. That's the thing. There is no magnetism in the coil, so there's no amperage. The only amperage leaving there is 195 milliamps out of the power supply, 24 volts. So that's 4.6 watts. That's because I turned it up to 24. It was at 18 originally.
Fascinating.
Have you hooked it up to a load whatsoever other than caps?
Just a resistor?
No, I haven't.
Try some LED lights.
Okay.
Yeah, you might find that you light a whole bunch of LED lights, but it won't light anything else. I don't know.
That's because of the nature of the LEDs, how they work, right?
Yeah, they're efficient. You can light an LED with microamps, so
yeah,
they're efficient.
But it won't show up on your watt meter, though. At least by the looks of what you got going on, it's identical to what I have going on in a sense. So my guess is that if you have LEDs running off your center pickup coils, it'll lower your wattage and you won't see it on your input.
Right. Okay.
Yeah.
I'll try that. I don't have anything. I've got a whole bunch of LEDs. I can put them on a one of those pop-in boards, I guess.
Yeah.
Yeah, breadboard. Yeah. And just I have a ton of them for another experiment I was doing. So yeah, I'll try that.
Looks great, Ian. Nice work.
Yeah. I just thought it was interesting. I wanted to get the half bridge up and running, but I just ran out of time today with work and stuff. So, but I saw this yesterday. I thought, well, if I make another coil and see if that's doing the same thing, it's similar, but it's not the same coil. So, but it's not interfering with the other one at all. And anywhere you put either of them in there, I'm getting the same voltage out of them. It kind of creeps up and down a little bit, but generally it stays pretty steady within about plus or minus 5 to 10 volt range. So
as a suggestion, the next coil you make for a pickup coil, do it identical to one of those two to see if your voltage comes out the same as the one that you copied. Yeah.
Yeah, that's what I was hoping to do this time, but just the difference of the sheath over the ferrite seems to have made all the difference. So I've got another one ready to go that I can wind with the same as that one, and I know exactly how many, how many layers there are in it. So then I'll see if I can get it to be the same. I tried a whole bunch. I tried a whole bunch. I tried smaller solenoids. I mean, these are out of a speaker system I picked up somewhere. So are these, but these are 1 microhenry. Those are 3. I tried little solenoids with ferrite cores. These gave about 5 volts, so it's like nothing, but nothing compared to these. These were just immediately in a different league altogether.
Yeah, Ian, are awesome.
Ian, when you place the coils inside the donut, you're increasing the inductance, so you're going to increase the load. So when you take out those pickup coils, then the inductance is going to drop, and then the resistance, it's called reactance, but the resistance of the coil is going to go down. So do you think that would be related to the change in wattage?
Well, it can't, because when I put them in, the watts go down, so there is no inductance. It's working in the opposite sense. And when I take them out, the watts go up. So
it might have to do with
taking
your
more.
canceled.
Look, if I take them out, look, you see, it's now gone. The watts, it's up almost up to 5 watts.
Yeah,
it's moving around, and I put them in. And I drop down. It's not by much, but it's like by 0.2 of a watt. It's obviously all in the current. So so if you watch the current 196, it's now 207. I put them back in. It's 197, so it's dropped 10 milliamps, where it should be completely the opposite.
Yeah, that's indicative of finding a scalar system, right? Or an ether tap system.
That's what I was hoping to do with the geometry, but when I saw the way that the windings crossed over, I would hate to see what this looks like on the spectrum analyzer. It must be the noise from hell coming out of it, kind of thing. But then you never know, because it was wound specifically to geometry and then counterwound over the top. So that's what I presume has cancelled all the magnetism, and it just leaves what's left through. I presume the geometry and the shape of the toroid, or however it's by winding it, not enclosing it. So I don't know. I have to try this one as well that I made. But I haven't had a chance to see what the difference is. Oh, well, it's the one that you've seen before. This one.
Oh, okay, that's awesome.
Yeah, I mean it's hollow. It's hollow in the center, but it's not finished for what I wanted. But I thought it'd be interesting because it's a complete section. It goes from triangle all the way into octagons. But I put pentagons in there, and I shouldn't have done that because the ratios are wrong. But in terms of what I was thinking, but the ratios are all. There are 2 of them together are 4-3. That's a perfect fourth. There's one of them is 3-2, which is a perfect fifth, and then there are 2 octaves between. Obviously the octagon and the square, and the hexagon and the triangle. So those are octaves essentially in terms of the number of sides.
Wow.
So, but the angles disappeared, as I told you before, because of the. But then angles in geometry, they can't really be there if everything is rotating and interacting. So you sort of think, well, maybe this is as useful as it being flat, because the rotation is being introduced into it.
You're getting it, Ian. You're on the ball, my friend. Definitely.
That unexpected result is amazing.
Yeah.
You're on something.
I see your coil as being constructive interference on the inside, but destructive interference on the outside due to the pattern.
Yeah. There's nothing on the outside at all.
Yeah.
But like I said, there's no magnetism. I mean, that's the testimeter. There's nothing. Not even off the solenoid coils that are getting all the voltage. I'm touching them right in here. Just zero. I just recalibrated it as well, so it's yeah.
Do you have an EMF meter?
Nothing. What's that?
Do you have an EMF meter, like a tri-field meter?
No, I was thinking again. I got one of these, and when I use this, I can't make head nor tail out of this. It's all over the place. I put it up to it, it'll show me like 800 volts sometimes, and I'll move it to another place and there's nothing. I move it back and there's still nothing. So I'm not even sure if I bought a duffer, to be honest, because it. Well, you see, I've got a negative now. It's 160 volts.
It's either that or your system creates such a deconstructive interference that it's shifting so hard, so fast, you can't pick anything up.
Well, possibly.
What's the name of that meter?
It's the FMX 003. It's the same one that I saw. What's his name? Gerald using.
Oh yeah.
Okay.
When he was holding it underneath and getting the 20 kilovolts, so it goes up to 20 kilovolts.
Wow.
So
that's high voltage electrostatic meter.
Yeah, electrostatic. It's an electrostatic tester. Yeah. So I mean, back
That's
here I'm getting minus 100. I'm getting minus 170, but I've taken it up to it. Boom, zero. And I was expecting there to be quite a lot of electrostatic energy from the coil because it was counterwound and there wouldn't be any magnetism. But again, once I put a half bridge circuit through it with I can put in 1700 volt impulses then in both directions, then that's when I was wanting to see if there was any major action coming out of it electrostatically just by driving it hard,
You might have created a negative electron well. Don't discount that meter so easy. You may actually be doing something that you don't expect. Do you know what I mean?
What does that mean for everybody who lives close to me?
I don't know. This is a new tech, my friend.
They keep telling me, don't be creating that damn black hole in and sucking us all in the bathroom.
Let's hope not.
Have you tried crumbling up very fine styrofoam and sort of dropping the powdered styrofoam on top of your coils to check for electrostatic fields because they have a tendency to react to electrostatic fields?
Good point.
Yeah, so they're supposed to cohere and start behaving as a unit, right? But if they're in a fluid, you get that. If they're in a fluid, you get that, right?
Yeah, you would just see densities or sparse where your fields are, and then you would be able to put your meter where it's dense to get the readings.
Yeah, it would stick to your coil too if you're creating negative electrostatics. Like, you know how styrofoam, when it comes out of the box and you're standing there, it sticks to your clothes?
Yeah.
Same kind of effect, if that's what you're getting.
Yeah.
Right.
Gotcha.
They're sensitive to electrostatic fields.
Yeah. Another good test would be if you have a battery-powered AM radio, stick it between stations where the static is, and then bring it close to your coil and see if you can pick up that frequency.
Ooh.
That's an interesting idea.
It is.
Yeah.
Very clever or creative.
I have an analog multimeter. I wonder if I could utilize that.
I don't know. Maybe.
Right. Interesting.
Gerald is brilliant.
The sad thing is, I gotta break it all down tomorrow and head back home on Wednesday, unfortunately. But this is my portal lab.
Nice.
It's getting so big now. I have to keep making stuff, and I keep having to take it with me just in case. Right?
It looks great.
It's like a version of hoarding, I guess. But yeah, no. But the yeah, I mean it's fun. But this is the first interesting result I've really got. So thank you, Gerald. I
Yeah,
appreciate that.
it's
This
very
is
interesting.
your circuit. It's the positive pulse. You know, it's what is it? It's about the pulse. It's about 96 volts. Yeah, like I said, I've got a decent ammeter, but or current probe, but you know, I hold it out here and it's still reading 10 amps, 10 milliamps. I put the
Wow.
clamp meter on the line coming away from the rectifier on the clamp, and it was giving me 3.5 amps. So I don't
Wow.
everything's behaving completely erroneously, because I know that's why I hooked up the analog ammeter, and that's up from 0 to 1 amp, and it's showing absolutely diddly squat. There's no amperage flow at all. So anyway,
So if everything's acting erroneously, I would suggest that you got something you're not expecting, and that you need to measure it differently in order to see it. Right. And that's why you're having. Go ahead.
Do you think the tri-field meter?
I think the tri-field meter would at least show you whether or not there's a radio frequency being produced and the electrostatic. And like you said, there's no magnetic, so it won't show up on the tri-field meter. But the fact that your electrostatic meter, your high voltage one, is showing odd voltages the way it is, that makes me kind of excited. That's interesting. I wonder if you had a shell around that system, if it would do something unique. You got me thinking now. See? I love inspiring people because they inspire me. That's brilliant. I love it.
You might want to try putting a Faraday cage around your test equipment if they're digital, because they're going to be sensitive to the electrostatic waves and can give you those erroneous results.
Good point, Sean.
So he's bouncing. He's got to be bouncing frequency everywhere for that static to act like that.
Yep.
That's the only way that it does it is when the frequency jumps really fast, too fast that more than it should. Then the static meter goes crazy. I have one, and it does it every time my plates are out of tune.
Or your computer will start going do-do-do-do-do, and it doesn't stop until you shut it down. Yeah.
But strangely, I'm not getting any of that. So I mean, the whole idea for making the coil was to try and see if the geometry and the cancelling out of the magnetic field would leave longitudinal waves going out of it, and and I'm not sure if that's what's affecting the pickup coils or the ferrite in them. But I don't know. I don't know enough about it, but to really understand it yet. But
so there's many different tests that you can do. Make a series of ferrite core solenoid pickup coils and stack them on top of each other to see how far your field goes on the inside diameter of the coil, right? And then do it on the opposite side of the coil underneath, and to the same experiment at a compass, so that you can see whether or not your top field is north or south, or if they're consistently changing, and if you can separate the north from the south by the coil itself. Do you know what I mean?
Yeah.
There's a lot of tests you can do to map that field.
Well, just using this the mandrolic magnet, there's nothing going on here at all. It's totally different.
Energy's got to go somewhere. Just because you don't see it.
Maybe there's a very slight south here, right on the top, but
energy's got to go somewhere. You may not see it, but it's going somewhere. Maybe it's sucking it in and then compressing it in your inner core.
That'll be interesting.
That coil may have a specific purpose that we're not aware of yet.
Yeah.
Yeah, don't discount it. Do what I do. Put it aside, build a new coil, and then if that one may have a purpose later, you figure out. It's happened to me a few times now.
To discover something.
Christmas ornament.
Yeah, or that too. Yeah.
Ian, the fact that
Okay.
you're using canceling fields, that's sort of counterintuitive. People want to strengthen fields, so you're just experiencing a different phenomenon that we're not familiar with.
Yeah. Well, that's actually, Gerald, I heard you mention earlier that you kind of gone off the rodent coil idea, right?
Yeah.
But at Tesla Tech this year, just a few weeks ago, they were on and they were using basically ratios and movement, geometric movement around the donuts that they were using. Now, they're using like Fisher Price donuts, that you give your toddler.
Yeah.
But at the same time, the wrapping is very specific for specific things that they want to achieve. They had antenna that were extremely powerful, and they were transmitting 86% of the energy that was going into them, and they were over
Wow.
unity. That they were over unity going into the antenna in the first place, and they were
Wow.
still
This is some of the
receiving
same
86%. Yeah,
Nice.
These are
it's
some
all
of the
that
same experiments that Randy Powell and Jack Scholes did too.
No, these are different. These guys, this
Different?
is the guy, John Viala, who's the Tesla Tech main person, and he's been working on these for years. And there's a ton of different effects.
It's interesting. Yeah, no, they had a similar method though. We're using the little donuts.
I was working on this one today. There's two coils that are counterwound. Or there's three coils. I've only done two of them, and then you overlay it going in the opposite direction. So there's it's field cancellation, but he says, I mean, they're looking very high end.
Is that when using a donut?
Spectrum analyzers. They're using really high end equipment to measure the fields and the coherency of the fields around these coils that they're building. And I'd never seen anything like this or heard anything about it before. But he did mention, and that's part of the reason why I did the 180 degrees out of phase. He did say that when you counteract and you cancel out the magnetic field completely, you're still left with the energy of the movement, because you're getting ether movement by actually causing the shift. But when you go back over, the ether is still moving. You're not canceling out the vortex movement of the ether as a fluid. You're canceling out the magnetic field associated with it.
That's
I'd be interested to see if anybody has any clips from that conference this year.
That's one of the basic principles that all my coils are built on, is the canceling out of fields, compress other fields, and allow you to form the flow of energy that you need for whatever it is that you're trying to do. Like Mission Control brought up phase conjugation. Yes, but there's a way of doing phase conjugation that's constructive or destructive. I don't play in the destructive realm, because now you're talking, things that can hurt people. I ain't into that. I want to see plants grow twice as fast. I want to see water get clean. I want to see the things that we know that this tech can do. So,
well, last year, I mean, this is interesting as well. Last year, there's a guy, Professor Robert Haralick, and he does a lot of work in subtle energy and with water. He did a presentation at the ESTC. I actually was there and I managed to meet him and had a chat with him about it. But he was quoting, I think it was a guy, Myers, and somebody. They've written a couple of papers basically on what they've done is they've taken. Oh gosh, what was it? Anyway, they brought all the frequencies down, and then they started to compile frequencies that were destructive or constructive. And they said that the main point of it was that the diatonic scale is both destructive and constructive. The constructive ones are the whole tones, and the destructive ones are the semitones. I thought that was interesting, particularly
that's absolutely correct.
the third to the fourth is a semitone, right? And then the seventh to the eighth is another semitone. So I guess we must be talking about the whole tones inside the diatonic scale and harmonics thereof, kind of thing. So I need to look at that video again, but I've always been aware that there are destructive, negative wave energies there that you have to be careful that you're not. And then I wonder about, I've got a multi-wave oscillator, and I think, hang on, it's giving me the full breadth of waves. So am I getting all the destructive ones as well as the constructive ones? But I've been using it for years and I'm still here, right? So, but anyway, but it's just there are many ways of looking at frequencies and what is good, bad, or indifferent. But Gerald, did I hear you say you had a mini spectrum analyzer that you use?
I do.
Do you find it useful?
Sorry?
Do you find it useful?
I do. I can actually pick up on frequencies. Like I'll put in, say, my main frequency at 1,000 hertz. And I can see that on my spectrum analyzer, but I can also see the other frequencies that are surrounding it. So it kind of gives me an idea of what's coming off the coil. I'm getting way more than I should, let's just say. Yeah, I'm going to do a video on with a little miniature oscilloscope showing the wave pattern at different points in the coil. And you'll kind of see where this thing's at. I get major spikes. I get ringing. Just depends on how I'm pulsing it and how the primary is wired to the secondary. That's another thing that matters. If you're running your primary and secondary in series or in parallel or reverse parallel, it all does something different.
Well, in this case, it's just a single winding, so it's kind of like two coils and one that are opposing, but they're flat laid against each other, I guess. So it's kind of like two coils, but it is a single winding.
Oh, so, I see what you've done. Okay.
So for every shape that I went, so if I go for a triangle, I go round, back round, back round. I'll do that round for that triangle to complete its shape. So I start at 24 and I end up back at 24. That's one triangle, just 3 points, right? But then I would wrap over those wraps exactly on top of them, straight back to the start, and then move on to the next triangle and do exactly the same thing all the way around, all the way back. So they're close coupled, and that was to cancel out the magnetic field. So I've seemed to have done that.
Yeah, you're producing an interference pattern by doing that.
You are. You want a golden nugget? I probably should.
Okay.
No, that's cool. Hey, that's cool, Ian. You said that you were picking up like 3 amps at some point. Like it was unstable though, or no?
Yeah, that was. I mean, I've used these clamp meters around this stuff before, and even this will be red lining, and I have to put it in another room to stop blowing it up.
So it's just picking up other stuff, maybe.
I've destroyed one of these already, and they're expensive. So I think I got away with it just about under warranty, but I don't want to do that again. They're expensive. So, but they're useful for electromagnetic stuff, but I'm not seeing a direct application for them. They work with a Hall sensor in them, so they could be useful for that kind of measurement. I guess it's still showing some kind of field. But
there are many different ways to hook up a system, so I'm sure you'll tinker with it and see if there's any other way of hooking it up, maybe.
I've got Evo's half bridge here, which is that's powerful. Those are extremely fast MOSFETs. They're 1200, but you can drive them to 1700 volts each. I mean, I'm not even going to do that initially. I'm just going to play around with it a little bit, and then I could actually go to the radiant power circuit, which is those 3 boards in there, which I can actually put them up in series and go up to 5,000 volt impulses. That's as much as the gate drivers can cope with. I discovered when I blew all the MOSFETs.
Oh no!
I had 4 boards. They're $20 each, and I blew all 8 of them on the 4 boards.
Wow!
And I was in Guyana, and I didn't have any more, so I kind of drew the whole thing to a halt. So, but anyway, but,
yeah.
But it happens.
But Alchemist does, yeah. But I mean, that's why I bought a whole bunch more as soon as they became available. They all disappeared during COVID for a while, as everything did MOSFET wise. But anyway, so yeah, I've got those to try, but I've just kind of run out of time. I'm hoping I'll get the half bridge onto it tomorrow. Maybe get another one of these made tomorrow, and then I'll just have to pack it all up. But see what I can get away with.
When we do our private class, you'll understand exactly what it was I did that you're not getting. And when you get it, you're gonna go and make 10 coils. I'm telling you. You're like you're in the same position as Ian. You're very, 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 very close. You're just about right there. Yeah. But again, we need to do a private thing.
It's informed guesswork still. That's the difference.
Yeah. Well, there you go. I got another couple nuggets for you that in the future will help you a lot, though. But you're doing awesome.
Yeah.
I'd love to test that field on the outside of your coil.
That's a lot of nice equipment to pack up.
Yeah.
Oh, I have to have see-through boxes because otherwise I'll never find anything.
I'm the same way. Everything in acrylic.
You need to build something that unfolds like a transformer. You hit a button and it just sort of unfolds, and then you're good.
Yeah.
Testing.
There's so many. I thought I saw yours on the acrylic on Wednesday, Gerald. I thought I should do that, and then I thought I don't have room to do that.
Yeah.
And that was all these boards everywhere. Anyway, but yeah, it would actually keep them. There's so many different kind of ways to set it up because I like to use on the radiant power circuit. I can put in positive or negative DC offsets as well to actually increase the voltage effects kind of thing as well. But it takes a while to set it up. I wish I was at home all the time. I could just set things up and leave them and go back to them, but I have to break it all down all the time. And it kind of kills a lot of projects dead. And then I find something new and more interesting, and I do that instead of finishing what I was doing before.
I got a couple boxes of those. I understand.
Yeah.
Hey guys, real quick, Sean, did you have to leave or are you good?
Yeah, I have to head out here. So I just want to thank you guys so much for having me on. Nathan, great job in facilitating these talks. I look forward to them all the time, but I have to head out, guys. Sorry. Thanks for everything.
Well, Sean,
thanks for being here.
Thanks, Sean.
Thank you.
Sean, we'll be in touch.
Yes, sir. Yes, sir. Take care.
Yeah, Sean, you're doing great work, by the way. Absolutely great work.
Means a lot. Thank you so much.
We'll see you soon.
Right on.
Awesome. I just got to shut my camera off to talk to my daughter for a sec, so please excuse me.
Oh, yeah, go ahead. Yeah, it looks like, Ian, you really got a lot of stuff going on there. A lot more than I do. I was just wondering the coil.
Yeah. Well, when I made that coil, I thought I need to try and do something with it before I just hang it up on the Christmas tree, you know.
Well, you made another small one.
No, I was just. Oh yeah, this one. Yeah. Well, this is for things that we're not allowed to talk about, right?
Oh yeah. Okay. Yeah. Sorry, I won't bring it up again.
But that's fine. No problem. But it does work extremely well for that, apparently. But I'm kind of an empirical sort of guy, and you know, people get on stage and they talk and they show you coils and say, "Oh, this one was for this, and this one was for that, and this one did this, and this one was that."
You got to test it and find out. Huh?
Show me. Would you please show me? But no, they don't show. They're not showing. But there's. I mean, he's very accomplished engineer. He's an old boy, you know. So he seemed to be on top of his game. And, but there was the most interesting side of this, which is the same wrapping technique as the rotating of 120 degrees of the rodent symbol. This is the coil that represents that. Okay, and that's why it seems to be as powerful as it is. So I tried to make a big one, but I find that the real use for these failures is actually propping up the coil over there so I can get the things in it.
Just put all the bad ones under the good ones, huh?
Oh, for goodness sake. You wouldn't believe it. I'm having a lot of trouble with PETG at the minute.
Oh, yeah, that's not fun.
Yeah, but yeah, Sean was showing me his printer, his 3D printer, and that's really nice. It looks it's not as big as I would have liked because it's not much bigger than the Prusa I have, but it's
What does he have? The Bamboo Labs?
it looks trouble. Yeah, he does. Yeah, Bamboo
Oh
Labs.
yeah, he's got it on Easy Street. That's
Oh, he does. Yeah,
Not as big as you like that.
Oh, Sean's
that?
got a fully enclosed Bamboo Lab printer that's got, you can put like, what is it, 6 rolls on the top. It's an amazing printer.
That's beautiful.
That's nice. It's easy.
Yeah.
That's it. Yeah. It's trouble free. He said the only thing he's had to do to it in 2 years is basically just put a bit of grease on the wheels, and that's it. So yeah,
we always have
it has my attention. Let's put it that way. After all my recent print failures, it's just such a waste of time, and you're waiting for something. I mean, this was supposed to be 8.1 inches, and I ended up 5.4 inches because that would print, the other one wouldn't. So anyway,
makes a difference.
Yeah. Yeah, I'll see if I've got a couple of screenshots then that I think you'd be interested in. Let me see if I can find them. See if I can figure out how to share again.
Give us the coil candy.
Yeah, well, this is not the coil. This is the actual. It's the fractal nature. It's a diagram showing the fractal nature of, you get that rodent symbol, and you take the center, the null point being the cross of the center of the V, right? Because he likens it to being a dual sine wave, like it's a helix wave, right?
Right.
So when you overlay it on it, I know, Gerald, you're kind of.
I used to think that. I did, and you know what? The rodent coil might be. It might be.
Well, it was the symbol. It was the mod 9 layout basically. So, but when you're doing the 1, 2, 4, 8, 7, 5 around the circumference, and you're joining the points according to that, you end up with that symbol. But if you take the crossing point, the 0 point, as the null point, and he says that's like the 0 point of the field, but it's 2/3 of the way down. It's not in the center. But what he did then was he rotated that whole structure around that center point, and he rotated it around 120 degrees, 240 degrees, and then back up again to the center. And that in itself rotated the whole thing around. And then all the forms that you make inside it, you get one big one on the outside. And interestingly, the sphere the circle that he put on the outside was actually 1.618. It was a phi ratio, and it worked perfectly. So you end up with that really nice like ratio in with that rotation. And then this coil is there are 6 windings to go on. I've done 2 of them anti-clockwise. I've got another one to do, third one. There are 33 nodes in this, and then you cross it over going the other direction, and that apparently is the equivalent of doing that, but in a coil format. So that's why I've been meaning to do this, and since I saw that presentation, but it's interesting. Yeah. And I find actually when I put this on top, as you do, right? I put it on top. I put it over the top of the solenoids, right, just to see what would happen. I put it one way, and it dropped the voltage maybe about 5-7 volts. I put it on the other way, and the kind of volts went up a little bit. So, but it's not finished. I was just playing.
Could be showing a directional pole, right? And that could be why.
Yeah.
One of the videos.
Yeah.
Sorry, go ahead.
I mean, that's just an open coil. So, yeah, 2 open coils.
I really like your work with the coils, Ian. They're beautiful coils.
Yeah, they're gorgeous.
Yeah. Well, there's something about gold and black.
Yeah.
It's
very aesthetic.
I like it.
It's very aesthetic.
Yeah. Very nice.
Yeah. Yeah. Anyway.
All these kittens. They're very loud. I know you guys can all hear them. I apologize. You can't quiet them down.
It's okay. They're excited about the coil.
Yeah. Yeah.
The entire chat has been blowing up all night about the cat.
I'm sorry, guys. Street cat dropped off 6. What can I say? You know what I mean?
Yeah.
Trying to teach them how to climb. So, oh well. What do you do? Yeah, I got some elements coming. I'm gonna have gold and silver coils pretty soon.
Nice.
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 Yeah. So we'll see what
Yeah,
happens.
Yeah, and then we're building a fireball on Sunday.
The which?
The fireball, the big one, the big rodent coil. We're gonna wind down.
Oh yes.
Oh, nice.
Ooh.
Very good. Did you get your wire in, Ben?
So no, what I'm gonna do is just use this one, and then for the last, because I'm just short 100 feet, I got the same spool over here. I'm just gonna come, I'll do it and then at the end of my 20 or 22 run, I'm gonna take this, cut it, wrap it, and then start this 2 winds, and then and then I'll twist it, and then it'll be fine. It'll be absolutely fine.
Okay. Well, trust you. See what you got when you're done.
It's just an extra step is all. I was thinking the more I thought about it, I was like, yeah, the advance and I wanted to show you guys this, by the way, before we end the stream. I don't know what time you plan on ending, but I have the screenshot for the new prototype of the Advanced 432 version 3. If you want me to bring it up for everybody to see.
Yeah, by all means.
For sure.
So this is from one of our subscribers, Mike Morell. We're trying to get him on as a guest next week. Let's see if I can bring it up. Okay, here it is.
It's all you hear. Crazy.
There we go. All right, so this is the new prototype that he printed, and as you can see, it's got the very thin opening, enough for one set of wire on top of one set of wire, and not for like a bundle.
Nice. Mm-hmm.
So it's very nice. Yeah, he did a really good job with this. A lot of credit to Mike Morell, and hopefully he comes on either next week or whenever he has time to discuss some of his work with the rodent coil.
Ben,
That's
what
cool.
gauge of wire? What gauge of wire are you going to use with that?
For the 432,
Hmm.
it's going to be a lot thinner than the one I'm using now.
Oh yeah,
You know what?
but you'll be using. Are you using Litz wire at all? Are you winding the wire before putting them in, or are you just putting them individually as wires? The reason why I'm asking is because anytime I've done this with pancake coils, if the wire is too thin for the grooves, they just start sitting side by side and interfering with each other. You can't get them nicely on top unless the wire gauge.
They need to be perfect. Yeah, you need. So I guess I need to play around with it to find the right thickness. But I'm assuming actually now that I'm looking at it, this 24 gauge wire might be fine. I don't think they were using anything different than 24 gauge. But yeah, they what they did is instead of doing it and twisting it all at once, they cut 24 or however many they had. I don't know how many spokes there are, and they laid them individually, one by one. So
right. So you're still spiraling them, right?
yeah. So you're still doing the interference pattern. You're going one way. Clock or counterclockwise one way and then clockwise another way with the same wire, and then you're starting another one doing counterclockwise then clockwise, and you still have that bend. Yeah, you still have that bend in the back.
Right. And so rather than bailing them all twisting them all together, you're actually just laying them one on top of each other.
Really delicately and evenly, so they're very evenly placed. And I think that that symmetry has a lot to do with maybe how it's working by not being multifilar, or but
that's a long wind.
Yes,
But
it
it
is.
yeah, it's definitely going to be a definitely going to be a long meditation session to wind that coil. Put on some techno
Yeah.
music and just run through it for like maybe 4 or 5 hours, hopefully.
Yeah, because also if the wire is too loose, it's going to keep popping out as you go around through the center as well, and it's going to be really hard to keep it in the grooves. So
That's
if it's something
true.
if it's something that fits snugly, that will really help you a lot with that.
That's a good tip. Thank you. Because you can't zip tie them. Like this coil frame on the left, you can zip tie that, for the interference pattern to get it to hold and maintain its shape. But this, there's no room.
You also have to have a smaller spool, don't you? Because that hole's got to be tiny in the center.
Yeah.
Oh yeah.
Yeah, exactly. Well, for this, I don't think you would necessarily need a spool. You would just lay them, because they're not going to be spooled up in multifilar. They're just individual strands of wire. You have 24 of them. 24. That's how I think it's wired, at least.
You'd still need them on some kind of a bobbin, because otherwise you'll be pulling wires
so they wouldn't
through the center, a big long lengths of wire through the center, and they'll be catching in all the grooves that you don't want them to be in. And then it's going to kink.
That's true. So you would need a spool.
Yeah, you can just put it on manually if you've got specific lengths, or just get a drill and just pull on as much as you need for the.
Well, what I used for the smaller rodent coil, I just used a Swiffer, the Swiffer handle, and it just had a spoke on either end, and it was a little bit smaller than a PVC pipe, so it fit.
Whatever it takes. My first coil build was a piece of wood and a bunch of nails. And a protractor to do the drawing on the board.
But yeah, if you could find like a PVC pipe that's really thin and small, I guess maybe.
Yeah, Gerald, I cut out that step instead of drawing on the board. I just 3D printed it out. That little ring, so that all the geometry is already done, and just had to put the screw in the hole.
I've seen it.
Nathan, you could 3D print a custom spool.
Oh, you could do anything you want with that 3D printer.
Yeah, I seen it.
Yeah, I just realized that.
That was gorgeous way of doing it. But again, I'm that old school. I took out a pencil, a protractor, a piece of wood, and I went to town with some nails and called it a day. So that's how the big coil was built. You don't need a 3D printer, but it makes it much nicer. Right.
Yeah.
Until you have to put 33 nodal points exactly.
Yeah.
I mean, that's a that's a design program. I still was able to do it in Tinkercad. You just pull up something that you can adjust the flower petals on. I think it was a sunflower, and it accepted 33. So you can then overlay it and then put all the spokes in and make the holes in the coil for the screws. So yeah, there's always a way.
Different way of building coils, though, of course. But yeah, that's. I don't think I can do it without a computer the way you guys have. That's for sure. I need a printer, by far. It would make things so much faster, right?
Oh, it does. It took me I want to say it was 30 minutes to print those things out, and it was so much faster. I think I would have driven myself nuts, because then you had to wind the coil after you just driven yourself nuts drawing it, right? Now you got to wind this thing, and you're like, okay, this way, that way, this way, that way. And don't get me wrong, you get a pattern in your head of numbers, and you can start winding super fast. Just don't mess it up.
Nope. You'll find out later once you look at the pattern and you're done your wind, you look at the pattern and you go, wait, that line's not supposed to be there. And you got to go all the way back. I've done it a few times. Yeah. When you're learning, it's tough.
Yeah. If you're using a 20 gauge, it's even worse, because they like to bend and stay bent.
Yeah.
I wound a little tiny rodent donut with a UV glue, and then I got to the near end and I realized I wound it wrong.
Ouch.
And it was all glued up and stuff, so I'm like, crap.
That's the end.
Yeah.
I find a couple of weird wrappings on that coil, and and I looked at it and I thought, oh, you've screwed it up somewhere, and it's obviously right. And then I realized that the triangles were just that much different from everything else. That those were the triangle legs that were actually seemed to be in error. They just seemed to be, what's that doing? Oh yeah, and then I thought, oh, anyway, yeah.
It's funny how that works. I remember my third coil I built, it was small, and I was following Russ Grease, and he had used hot glue for his, and I knew nothing about circuits at the time. So I was spinning this magnet, heated the sucker right up, went to pick it up, and it just went all over my hands. And it was bad, man. But that's how you learn, right?
I guess so.
Yeah.
I'm just looking for this.
So yeah, I definitely can't wait to wind this one. This is gonna be a fun project.
Looks like it.
It's gonna be good to see it all done. That's for sure.
Oh, mama.
Massive shout out to Michael. Oh, I'm sorry. A massive shout out to Michael Morell. And if you're watching, Michael, please reach out to me. I emailed you if you're interested in getting on as our guest next week or any Monday of your convenience.
Hold on.
So, have any of you spent any time looking at Bob Greenyer's the fractal toroidal moment?
Yep.
A little bit, yeah.
Because I was thinking to design a nested toroidal coil to the same. So you've got the large one on the outside, and you've got the 4 inside, and then within those 4, you've got 4 more, but they're all orthogonal to each other. And if you get the winding correct and figure out how you're going to get the wires out of the little ones to the outside somehow, then I thought that might be quite interesting.
You're talking
a long project.
Yeah, that's the design.
That's the bagel coil, correct? That you're talking about.
It depends. I mean, it's fractal, so it's all to do with the moments that are produced by each little coil within the coil within the coil, and they all are orthogonal to each other. And it seems that I just thought it was very interesting.
A personal warning for the bagel coil. I believe it's doing something to, we'll just say, anatomy that they're not aware yet and won't be aware for a while. But once they figure it out, they won't be making them anymore. Does that make sense? That's just
in terms of the.
And hey, I could be wrong. Sorry.
The toroidal coils.
Yeah, the bagel coils that they've been building for the last 2 years or whatever. They're interesting coils. They definitely do what he says they do, but it's uncontrolled, and that makes me really nervous. So upon looking at it, I see a deconstructive pattern that I can't say for sure, but I wouldn't personally want to play with it. That's just me, because I don't want to take the chance of it destroying cells, you know what I mean, and causing the C word. I don't want to say anything like that on the channel. I'll stop. I'm sorry, I'll stop. But yeah, so we have to be careful when it comes to doing certain tests, certain things. I could be wrong. Yeah. I've been proven wrong before. Like I said, I'll admit it if I am. But I don't know.
Yeah,
I've stayed away from that one.
It all seems to me, it seems to lend itself to again just the implosion in the center again. You know,
it looks beautiful.
And does it? I haven't seen anything about the coils he's made. I've just seen the lectures that he's done on it.
It looks feasible, right? The way it's presented, it seems feasible, but the way the energy flows isn't so straightforward. It likes to spiral and it likes to spin, right? And it's usually on the outside circumference of the wire or the line or the direction that you're trying to make happen, usually. And if you're not taking that into account when you're actually engineering the system, you might get a deconstructive pattern that does things you don't want.
Yeah.
You know what I mean?
Not beneficial. So
yeah.
So what do you think? Do you see a way then of cantering the coil so that they're not completely orthogonal? That would encourage a different kind of movement that would potentially be more constructive than, or is it just still uncontrollable and does its own thing?
With the system that they're playing with now, is that what you're asking? Like,
yeah,
the bagel coil system, could it be canceled? That's a good question. I would think you would actually have to.
If they're not completely orthogonal, they're not that 90 degrees within the 90 degrees within the large donut on the outside, right? If they're offset in some way to get a different behavior out of it, I wondered if that. I'm picking your brains, Gerald.
You know what? I see the field as being the only way that you can fix that is actually to redesign the coil to some degree. Because of the way that the field is produced and cancels out in that coil. I could be wrong, but I don't know. I don't see anything good because of where the destructive pattern shows up when the coil's running. At least in my mind. Maybe I'm wrong, like I said. I could be wrong. But
if you have any links, I'd be really interested to see the work that they've done on, because I haven't been following it much. It was just I saw his presentation at Tesla Tech or Cosmic Summit, was it? I can't remember, but it was one of those. And I thought, oh, that's interesting. So
he's definitely getting those productions and the transmutations and everything. Like he can prove that all the way. I just wouldn't want to be in the same room when that system's running. You know what I mean? Like personally, I could be wrong, but I wouldn't want to be in the same room. There was another gentleman about 3 years ago. I won't mention his name, but he came on making claims about certain systems. And he had said that it was very hard to build the system. It was unique. It was this, that, and the other. I took one look at it. I made it. I tested it. The destructive interference in that coil made my stomach hurt. So there's certain systems you got to stay away from, and certain systems that how do I put this? They'll add to the bonuses of the coil. Right? I'm trying to be very cautious. You know what I mean? Like plus energy, I'm saying. You know what I mean?
Yeah. Constructive energy. Yeah. So and the other thing I'm thinking to do, so I was talking to Sean just on Messenger about it, is building his spherical coil, but counterwinding the two hemispheres. So you're basically two separate coils, one in each hemisphere, but both counterwind, and impulsing those and see what interesting things might happen in the middle. Because I mean, in geometry, when you enclose anything by a circle, it sends all the energy to the center. Apparently, when you surround a triangle with a circle, it takes the energy that appear at the vortices and it draws it all into the center.
That's what it's all about.
Are you aware of that? I mean, this is what I've read. Whether it's fact or not is to be.
No, that's.
And I guess if you do that with a sphere, and that's why I was thinking. That's why I kind of went for the toroid version of your inspirations and stuff. So I thought, well, if I can get the rotation into it, then, and by doing that with this, might be part of the reason why everything is going into the center as well.
You're absolutely correct. And as a suggestion on your next coil, don't try and wind it around a toroid. See, second day with my new tongue. Don't try and wind it around a toroid. Try and wind it in the idea that it's going to form a toroid. So
Right.
build up a flat plane, like a 2-dimensional flat plane would, into a 3-dimensional form. Try and think that way, and it'll come together a lot easier than you think. Whereas, like, I understand where you're going, and where most rodent coil people go, is they wrap it around the toroid or into a shape of a toroid. Whereas you're not trying to make it into a toroid as much as you're trying to capture the natural flow of energy and direct it into the form of a toroid.
Right,
Yeah.
a vortex.
Yeah, exactly. And a vortex will do that, providing you use sections of compression.
And you have a spiral, a left-hand spiral, which is, I think explosion, and then a right-hand spiral, which is compression or implosion. Or I could have it backwards, but one is explosion and one is implosion.
Yeah, implosion at the center, and the north moves quicker than the south. Let's just say it that way.
Huh.
Yeah.
It's just you're only seeing half.
That's why one's blue and the one's red, because they're shifted, right? Temporarily, right?
Huh.
This is all going to come out very, very, very soon, guys. When I do my presentation, you'll get all the golden nuggets, and everybody's going to be flying before long.
I gotta ask, is that anytime soon?
Much sooner than I would like. Let's put it to you that way. Very soon. I had a breakthrough last week, and I had to incorporate it into the presentation. And I did, and I was almost complete at APEC. I threw my back out, and I didn't get my editing fully done for the video. My editing's almost done. So as soon as that's done, I'm going to do a presentation on Nathan's channel. And we'll go live, and I'm just going to let it roll.
Nice. I look forward to it.
Very nice.
Nice.
Hey, I wanted to show you guys something just real quick. I know it's not as fun as what you guys do, but I wanted you to watch. This is my Tesla coil here that's hooked up to my gravity flare, right? You see the little wire going down the top?
Yeah.
Yep.
And watch when I put the light next to it, what happens. Do you see when it turned on?
Hard to tell. Was it closer to the top?
Yeah, closer to the top where that wire, I'm betting, when you put that wire down there, that's where the wire starts.
So it resonates in the 900s, that coil, but you have to minus 310 kilohertz from that, because that's what the gravity flyer is. So what I'm showing you is the bottom of the coil is not in resonance, but the top is. Does that make sense? So it's not getting that same amount of windings on the bottom of the coil as it does on the top, because I changed the amount of capacitance in the coil, or the amount of windings in it, based on adding the gravity flyer.
Yeah, because of the wire that goes down the middle, right?
Yep.
Yeah. That's awesome.
So by adding, normally you call a load or whatever it is, the gravity flyer you want to call it, by adding that, it reduces the frequency. So just so you know, there's a trick to these things, and those coils you guys wind are kind of the same way. They're going to act similar, just like that, and it won't light up till you get, right in the right spot. But I just thought that was interesting.
These coils are like compressed Tesla coils. That's kind
of what they are.
Yeah.
Yeah.
Just in geometric form.
Yeah, I was gonna say, I keep telling people they don't understand because of the shape. They think that they're not, but they really are.
Yeah.
You can take your Slayer exciter circuit and run it to it, and it's gonna work like a Tesla coil.
Yep.
Yeah.
Yeah. But that's when I was doing the pancake coil. There was a lot of wraps, and what was I going to say? The only way I could keep the formers together was having neodymium magnets and little pockets all around the outside of the actual former just to clamp it together. If it was too strong, you couldn't get the wire through the gap, and if it was too weak, they bunched up, and it was anyway.
It's a fine balance.
Fine balance. But when I was waiting for the epoxy to cure, because I put it all in there just to get it all solidified, and I thought, oh, I'll just check the inductance of it. And I looked at it, thought, oh, I can actually look at the resonant frequency of it as well. And I looked at it, and it turned out it was about 280 kilohertz, just plain. And I thought, oh, success, right?
Yeah.
And then I took the magnets off when the epoxy had dried, and it dropped to 189.
Oh.
So the magnetic fields from the magnets were obviously creating, I guess that would be a higher inductance. So it was less inductance, because the frequency was 100 kilohertz higher with the magnets attached than it was when I took them off.
Wow.
And that was 1/3 of the entire resonant frequency, because it was a let's say 300, and it dropped to 200 when I took the magnets off.
That's interesting.
Yeah.
That's like the Meg, right? He uses magnets to increase the frequency in that as well. That was Thomas Bearden's solid state system. Magnetic electric generator, I think he called it.
Huh. I don't know that one. Yeah.
All right, guys, it's getting late. It's
this cat's driving me nuts. Sorry, guys. Every second I'm muting because all your.
It's all good. Hey, Ian, thank you for coming on and presenting all that stuff today. I appreciate it.
Yeah, thanks, Ian.
Absolutely.
Well, you're welcome. You're welcome.
Good job,
Ian.
Seriously.
It's interesting.
Yeah, you know what? You guys are awesome. I thank you for taking on building my coil, and soon enough I'll just give you all the info and you'll just do it all on your own. You won't need me no more. I'll just,
I don't think so, Gerald. You're here to stay, buddy, no matter what you come out with.
Well, either way, you know what? It's good that you guys are working on this stuff. I hope it benefits you large. And I gotta deal with these cats.
This is the cutest ending we've ever done, ladies and gentlemen.
There's like 6 of them sitting here, and the mom's right there, and they're talking, I guess.
A kitty climactic.
Oh, that's funny. Yeah, thanks for having me on, and I appreciate you coming on. Ian, your work is awesome. Please keep it up. Same thing with you, Nathan. That's a really nice coil.
Oh, thank you. I'm trying.
Yeah.
Oh, yeah, you're getting there. You guys are both getting there a little faster than I thought you would. It's great, though.
It's simply numbers, Gerald. I told you. You're not going to hide something from me if it has to do with numbers.
And I'm not trying to hide. Not at all. But I do like the fact that you've taken it on as a challenge to try and figure it out on your own. And then, like I said, if you run into a brick wall, I'll give it to you by far. It's not about that. I like the fact that you took it on as a challenge.
Well, things that don't work annoy me, so I have to continue to do it again and again and again until it starts to work. It's pretty soon I'll have this thing broken down into 4 coils. I'll have each one resonating. I'll find out what the cross fields are. Then I'll be able to wind it the correct way, because there's a pattern in here I'm not seeing. Once I see that pattern, it's over. I'll figure it out. But
you know what? I really
what it takes.
I want to go back and tell you, but I won't. And when you do figure it out, you're gonna be amazed at how simple it actually is.
Oh, it probably is.
Yeah.
It's not
difficult.
Yeah.
One question I meant to ask when I was asking about your spectrum analyzer, the mini one. What do you actually use for your pickup? What do you actually?
I use
a radio antenna.
Yeah, radio antenna. One of the telescopic ones. Attaches right to it. Yep.
Oh, really? Oh, okay. Oh, sweet. That's good.
Yes, I'm giving off magnetic field, electrostatic, and RF, and something else because it goes through everything: aluminum, glass, wood, even my battery. It went through my battery, so it goes through lead. Crazy. Yeah,
Wow.
you'll get there. You'll get there. You're already producing the same energy. You just you gotta move your fields a little bit. That's what I see. And Nathan, he's already got the concept down. Pretty soon, he won't have to move the fields. He's just gonna go, and it's gonna turn on. All right. And then we got to do that Star Trek thing, Nathan. I'm telling you, with Ben and I'm telling you, we got to do that.
That's the greatest idea
Yeah,
ever.
man. Ben, you're there. Gotta wait till you hear his idea off air. You'll laugh. You'll love it. I freaking laughed.
I told Ben we got to create a Star Trek thing with everybody that comes on the show, and then us as characters on there. You know what I mean? And
would be the doc.
Oh,
right?
That's a great idea.
nice.
I like it.
Bones. Right? Bones.
We're gonna put Ben in a lab with Leonardbot over there. You know what I mean?
Yeah.
But the thing is, we don't get it'll be like that Tool Time show. You won't be able to see Ben's face half the time. You got to see the back of his coat. So every time you walk in, you can't see his face. You have to see the back of his coat.
Yep. And then we get Myke on the transporter.
I know what you're talking about.
Yeah.
That's funny.
Mike's got to be the transporter chief. And he's
Yeah.
always got to tell us how it works every time we communicate with him.
And Ian's the one keeping us logically and grounded and in check like the doc does. I love it. I love it. I'm telling you.
I'll keep telling everybody we're going to go into this abyss here and don't worry about it. You know what I mean? That everything's going to work out. And we'll all go on a big adventure together.
Damn straight. And Anthony keeps telling me to pet my kitty.
Oh,
You know how hard it is to catch these cats?
oh yeah.
They like scatter. It's amazing. They're fast.
Yeah, got to get out your shoelace and just spin
Yeah.
it around.
That's true. I'll try
That way they become your friend.
Yeah. All right.
I can just
Again.
see one crawling up the back of your wallpaper in the background.
This they've already tried.
They've already tried.
Surprised
Oh.
you didn't see 'em. Earlier they were hopping up on the whiteboard and they were trying to because I was drawing and they're trying to get at the marker and
Nice.
they're at that age, right? So it's funny.
Nice.
Right on, guys. All right. Thank you very much. I want to say thank you
Thanks,
to Sean
guys.
out there. Sean, thank you for presenting today. I appreciate it. Ian, thank you for presenting today. I really do appreciate it, guys. Thank you very much for coming on and having fun with us today.
Absolutely.
Thanks,
We'll see you
everybody.
Wednesday,
Thanks, Nathan.
everybody. A little later than normal, Nathan.
Yeah, you got it. You want to go an hour later?
Yeah, that'd be cool. I should be ready then.
I'll set it for then. All right, guys.
Awesome.
Thank you again.
Thanks, guys.
Have a good night.
Good night, everybody.
Right.